world we live in has just one way to go, into the future of technology. Our mission is to be part of this journey. We are reinventing the way of electronic components distribution. We are there at the tops of the highest mountains and the bottoms of the deepest oceans. We are there in the killing frosts and the roaring flames. We are there where one's life is celebrated and another's is struggled for every day. From the simplest to the most imaginative solutions, we can help you reach your goals. If you wish to use the light of the sun, if you desire to tame the power of the wind or the sea, if you want to drill deep down or reach up for the stars, we will be there. SOS Electronic everywhere.
Ladies and gentlemen, technical enthusiasts, let us drone directly into the world of technology, into a world of hardware, software, digitalization, IoT, and artificial intelligence. We will deliver these topics via our this year 2022 DEBATECH conference right now online. It's going to be really special. The specialty is due to the fact that a lot of you have shown an interest to see this conference across the world. So we are not going to stay local. We will deliver our conference across several other countries. All those we will deliver the speeches on a local level, although individual shots will be delivered in a local language. We've prepared for you captions. Without further ado, let me invite you directly into our conference, DEBATECH 2022. Enjoy. Dear technology friends, let me introduce Mr. Heliodor Macko from SEEK company with very special topic of today, which is renewable power sources for EV, charging and e-mobility opportunities and outlook. Heliodor is a successful and great enthusiast in terms of technologies, specifically in the field of charging stations for electricity vehicles and intelligent lighting poles. Let me ask you naughty questions. What car do you drive?
Well, of course, it is electric car. This is normal that the car is electric. However, I had to say that in front of your studio, there is no charging point. You need to think about it.
Oh, I will have to talk to the director or to the team, or maybe you can help us with this challenge.
I take your word for it, and let's discuss this afterwards.
Great, thank you.
Dear technology enthusiasts, let me introduce to you a topic of charging from lighting poles, because I believe that this is something that will play an important role in getting to net zero when it comes to carbon emissions. Before I talk about charging itself, I will talk a little bit about smart lighting, because this is connected with this. Did you know about the fact that 1/5 of global energy consumption comes from public lighting? This is quite a lot of energy. And with smart control of lighting, we usually save about 40% of this energy, which means this is indeed quite a lot of energy, and with today's prices, also a lot of money. So let me tell you how this works in reality. What is the smart lighting? First of all, we need to control each individual lamp. We tell each individual lamp when it should be on, when it should be off, and when it should be at what intensity. This is the most important part where we take the energy savings from. Second thing, we are providing remote diagnostics. That means if there is some problem with the lamp goes off or it's hit by the car or something, then we need to know and we report the fact before people complain or before some additional accident happens. On top of that, the lighting provides, of course, automatic mode, which means we are adjusting the lighting period precisely to the changing lengths of days and night. We are providing motion sensors. We are, of course, providing energy monitoring and reporting so that you know exactly how much energy you have spent and how much energy you have saved. And by the way, when we are talking about the public lighting is actually a great network because it is already installed everywhere where people live. And lighting poles are a great place to have additional Internet of Things sensors like MeriTO stations and carbon emission sensors and different kinds of tools that makes the city smart. How do we do this? We are manufacturing modules that we put into into each lamp and then into electrical cabinet. And this provides us with the communication method, how to talk to each individual lamp to tell it what should be the intensity, what is the current condition of the lamp, etc. But the most important part about this is that if you run a simple calculation, that when you are thinking about changing your lighting from old sodium yellowish light into much more effective LED light, and you calculate your return on investment, you will find that when doing this, of course, making the public lighting installation smart and controllable does add to an investment cost. However, it brings additional savings, and these additional savings allow it to have return on investment much faster than if you did it. So it always makes sense in the city, if you are switching the lighting into LED, you need to do it smart immediately, and then you save much more money. How does it work technically? Of course, this is not something that we would invent itself. The lighting control idea is not very new, and there are different approaches how this can be done. One, maybe the oldest approach is to simply stick a SIM card into each lamp, which will allow each lamp to communicate, and this is the communication method that allows us to do the smart lighting, which works. It's fine. The only problem is that that the cost of communication for each lamp actually costs so much money that your savings, what you save on energy, you are actually paying for the communication and for the equipment. So this is not exactly the best type of thinking about saving. A little bit newer approach is to use radio mesh networks, which are based on Wi-Fi or Bluetooth or different protocols. And basically this works so that if you have lights, street lamps on the street, then the first light sends the command to the second light, that sends the command to the third light, to the fourth light, etc., etc. And all these lights are in clusters, and they are exchanging radio data packages. And this lives in a sort of big radio network where everybody talks to everybody. It is a little bit messy, and the main problem, this is also working and it's fine. The only problem is that every time when there is a new building or a new tree grows larger, and we are losing the communication between two lamps, then the system needs to find a way around that. However, as long as our streets are usually linear, we have a problem and we lose the communication. And this is happening this is happening pretty frequently, that somebody needs to go and add additional antenna somewhere and solve it. We at SEEK are using different approach. We have developed Internet of Things communication protocol for power line, which means we are communicating with the lamps over the same wires that deliver 230 volts to the lighting, which means as long as we have power, we can communicate and we need no antennas and we need no complicated mesh protocols. And it is pretty stable. As this communication type has been invented especially for lighting control, this is a low-frequency power line communication method, and it is patented, and it allows us to communicate over 5-kilometer distance between the electrical cabinet and the last lighting point. In Europe, the largest power line for public lighting that I have seen was about 3 kilometers, so we are good to go for practically every type of the electrical grid. And also, as this type of communication is low frequency, it is extremely stable, which means we do not really care if there are trucks or trams going along the way. This does not affect us really. Now a little bit about the electrical cars. Electric cars are very cool, and if you try to drive electric car, there is a big chance that you only are thinking, where am I going to charge my next car? Because you are already sure that your next car is going to be electric. This is how it works, and this is what worked for me. I made so far something over 300 kilometers already electric. However, when you get home with your new electric car, and you don't have your own garage with your own charging point, you need to think about where do I charge my car? It is not exactly practical to go every other day into a shopping mall to plug your car. So it is very important that if you are parking your car on the street, that you have a place where you can charge the car. And not by having the cable from your window somehow to the street, because that's not maybe the best idea. So we had decided that we are going to combine these things, and we have integrated these two technologies, and we have developed a charging station which is integrated into the lighting pole, which is using this patented low-frequency power line communication to talk to the central system, which is also managing the grid. And this allows us to convert practically every lamp pole on the street into a charging station. How does it work technically? As these charging points are not isolated but are communicating over the power line with the lighting system, during the daytime when the lights are off, all the capacity, electrical capacity that we have on the street is used for the cars. So in this particular example, if we have 30 kilowatt capacity and we have two cars charging, then they are sharing this capacity based on the needs and capabilities of the cars. Not all cars can use full capacity for the charging. There are differences between different types of cars. In the night, if we have smart LED lighting, then let's say we would be using 5 kilowatt out of this capacity for the lighting, and the remaining 25 would be again split in between the cars that are charging. I have here a little animation that shows how this works in reality. So imagine we have a street and it's daytime and the first red car comes and it basically gets all the capacity for charging. When the green car comes, the capacity is changed and they split the charging current. And when the night comes, all the cars and the lighting are sharing the full capacity. When the red car, because that was the first one, is charged up, then it waits and we are splitting the remaining capacity again with the cars. And when the light is dimmed, for example, after midnight, again, we are using this capacity for the cars. Whatever is happening over the night with the system, automatically, the most important thing is that in the morning, all the cars are charged up. And this is what we call load balancing between lighting and charging of the cars. And this allows us to provide charging stations practically on every street. Now, the technology is here, and we have implemented it already on several places. And let me share with you some thoughts, what to keep in mind when thinking about this kind of charging. So first of all, you need to have parking places which are next to the lighting pole. Sometimes this is not the case, sometimes this is the case. If the lighting pole is next to the parking places, of course the best is if the cars are parking perpendicular to the sidewalk, because then we can reach with charging cable to many more places for the cars. And typically the charging cable that every electric car has is 5 or 6 meters. So in this case, we do not need to have the charging place reserved only for electric cars, which of course would, on the congested places, would not be the best thing to do. Second thing is we can convert the old lamp pole by providing a special type of wall box which will be hooked on the old pole. Or if this is a new installation, for example, we can provide a brand new pole with all the electronics integrated already into the pole. It looks nicer. It looks, and it is also vandal resistant. I often get the question about the capacity because, of course, this is not a super fast charger, because for super fast chargers we would need to have special transformers and much capacity. This is type of charging which is where we expect the car to be parked there on the place for several hours. And for convenient charging of the cars, 11 kilowatt is today the best option. However, it still makes sense even if it is 5 kilowatt. And here in this table we have different types of electrical wiring which is used in European cities. And as long as we have, for example, copper 6 millimeters square cable, then typical capacity which is available is over 40 kilowatt that we can share between the lighting and the charging, which allows us to have on that street 4 chargers with 11 kilowatt each, or 8 chargers where they will share the capacity dynamically, because we do not expect that 8 cars will come all at the same time. And if it does, then they still get 5 kilowatt, which is good enough for the car to be charged in the morning. One important thing about why this has to be linked with the smart lighting. Well, because if you don't have smart lighting, then during the daytime there is no energy in the lighting pole, because the power is cut off. But we want the chargers to be operating 24/7, so we need to make sure that there is power 24/7, and during the daytime the lights are off at the same time. We can do that, of course, even without changing the lighting, by providing power line modules with relays that we install into the light, and that allows us to have during the day the light off while the power is still on and the charging stations are operational. Now, another question that I typically get is, well, and are you then going to give away this energy for free? This is not fair. Of course, this is not fair, and this would not be sustainable, because with the growing number of electric cars, there will be also growing demand of energy. For your information, in this type of charging, a full tank or full battery of the car, the cost of this energy is somewhere between 4 to 7 euros in today's prices. And so it is not a huge amount of money, definitely not compared to the gasoline cars. However, for this to be sustainable in the long term, we need to charge money for the energy. And we are providing a software system for the municipalities that want to implement this kind of system. We collect payments from the people for the charging, and by the end of the month, we are providing this type of report to the municipality, where we show all the charging sessions that happened during the month, when it was, how much energy we have consumed, how much money we have collected, and after deducting our commission, we are then submitting or remitting this money to the municipality to cover the energy cost. So that this is the way how the municipality can provide cheap on-street charging possibility for EV car drivers at very low cost. And what does it mean for the electric car driver? I come to the lamp pole, I plug my car in, I open an app on my mobile phone, or I scan QR code which is on the sticker on the lamp. I log in and I press the start button to start the charging, and this is all. So after finishing the charging, the respective amount is taken down from my credit card, and I receive an invoice for my charging into my email box automatically. That's all. We are trying to make this very simple, or as simple as possible, for the drivers and also for the municipalities. And yes, we are manufacturing all of these electronics here locally in Prešov in Slovakia. And so this is indeed European made. And thank you very much for your attention, and I hope that your next car is indeed going to be electric and you will have a place where to charge it. Thank you.
Awesome presentation. Thank you very much. But let's move further. Let me introduce Mr. Peter Feciľak from Feciľak company with great topic. MeriTO measurement and analysis of consumption in real time. Not an easy one. I'm sure he will elaborate. But prior elaborating, I will introduce him further. Peter is an associate professor at the Faculty of Electronics, Engineering and Informatics, Technical University in Košice, mainly focusing on communication and infrastructure. He will lead us through and elaborate on topics like MeriTO, today's 15 minutes performance, 5 measurements up to real-time level. Prior moving forward, let me ask you a question, of course. Why have you decided to establish or to create a startup?
Thank you for the question, as well as for inviting me for a presentation for such a great event. Let me answer that in a way like I was working on different research projects at the Technical University more over the decade. And we've been always faced to the lack of the feedback from real customers. So we designed solutions which were progressive with the problem of a long time delivery to the market. So this is especially true when you are working with the students. And therefore we decided to establish the startup in order to transfer some of the research results which we had into a product which would be available to real customers, and through that we would be able to get a real feedback.
Thank you very much. Handing over to you, you can proceed with your presentation.
Thank you very much. So, dear ladies and gentlemen, it is my great pleasure to share with you what we are doing at the CEE Labs, the university startup, and the product called MeriTO, which is supporting the monitoring and the power consumption analytics in a real time. Before I'll go with the technical details, I will briefly overview you with our team. Most of our employees are the university graduates or the PhD researchers. We all had a passion for technology and innovations. Our professional background is in a computer networking and the cloud technologies. And one day we decided to change the world of the energies, the world of Internet of Energies. So here we started to focus on a problem of a high energy inefficiency and simply dealing with how much energy is being wasted in different types of buildings. And this may be especially true for some university areas or secondary schools and so on and so forth. So we started to focus on the standby consumption. And let me tell you that while the residential customer is able to save about 60 euro per year, when we are thinking of a little bigger environments, the company campus or the city hall of Košice, for example, which is depicted on the picture, here we can save about 40,000 up to 60,000 euro per year just in a standby consumption. And the problem of a high energy and efficiency linked with the standby consumption is not only the problem of manufacturing, the cities, the governmental organizations, schools, but basically of all of the institutions where the residential customer is not feeling responsibility for the energy management. And usually it is due to the fact that the residential customer in such a building is usually not the one who pays the bill, right? So with that, we were thinking about providing better tools for energy management. And let me tell you that while we've been talking to many facility managers, we identified that there is really a lack for such a data and tools. So to properly understand where is the root cause of the energy wasting. We created a solution which we call the digital energy officer of a managed objects. And that's basically a technology which is installed in a wiring closet together with the cloud-based software, which is using some AI algorithms in order to provide in-depth data about where, when, and actually also by what is energy being consumed. Just after you would have a proper understanding of your internal environment, then you can also reduce the carbon footprint in a controlled way and simply also to save some money. So this is a technology that really helps to cost savings. First of all, our technology called MeriTO, so therefore the presentation is called like the MeriTO, the analytical tools. The MeriTO is kind of unique when compared to the other power consumption meters, where we are usually having 15-minute load profiles. We created the technology that is providing a 50 millisecond samples in a cloud for data processing. So the key in our technology is really in granularity. And this is something like it is really suitable for a machine learning algorithms in order to identify or deeper, provide the deeper data from the environment where you are operating such a metering system. So here with such granularity, we can create something like fingerprints of every single electrical equipment or device which is being operated inside of your building or a household, and recognize the individual equipment as it is being operated inside of a monitored building. I used to say that we are like a Shazam in electrical wiring. If you know such a service, which is helping you to recognize the song you are listening to by some patterns, we are using something very similar. So we are able to recognize the device as it is operated in the building by the patterns. And with that, we know when the device has been turned on, if it has been turned off, or maybe the more important thing is if it remained on somewhere where it is unseen by the people. And that's where you are able to then allocate the particular equipment and save some money also from its operation. Currently, we are in an MVP state. It is a certified solution, and we have more than 300 pilot installations. From a technical perspective, it is a single point and a three-phase, four-quadrant real-time metering system. And on the right side, you can see some of the installations. So this can be installed, for example, next to the power meter somewhere outside at the pillar mount wiring closet, or it can be installed somewhere inside of the building. Of course, in a wiring closets. From a technical perspective, it is the semi-direct and a non-invasive method. So we are actively monitoring the voltage, and passively using a split core transformers, we are measuring the current. From a perspective of accuracy, we are reaching up to 1% on an active power, and with that linked also the active energy. From a perspective of communication and connection up to the cloud, we are using an 802.11 Wi-Fi interface, which connects to the local infrastructure in your building, or if it is installed in a household, then it connects to the local access point. And we are also supporting the LoRaWAN technology. Those of you who know, the LoRa is for a long distance radio. And basically, there is one small limitation from the perspective of amount of data which you are able to transmit over the time. So with that, it is very easily usable in a large area where you need to cover some kind of metering. But from a perspective of analytics, it is really better to use the typical 802.11 for real-time communication. But I understand that in some of the cases when the area is kind of large, it may be really difficult to build up an Wi-Fi infrastructure. And regarding the new technology, and I'm sure that you listen also to a number of topics which has been presented also within this conference. Trendy is 5G. So from a perspective of a modular architecture, we are also a 5G ready right now. We do have also an RS485 interface, which allows you to connect to bus devices on this interface. Typically, you can do a remote readouts from power meters, for example, to get also the billing data. Or you can connect that with the local devices, which allows you to maybe more effectively manage the consumption of the energy based on the currently measured data. And this is especially useful, for example, in a photovoltaic systems. So in case that I'm producing and feeding the network with the produced energy, I'm maybe also consuming that just by turning on some equipment which is already laying somewhere at my house or at the building and could be used for that purpose. Once the installation is done, We do have also a cloud interface, and finally also the user interface, which allows the user to manage all of the devices which are installed inside of the building. This is done in a kind of a hierarchy, so you can structure that in a way like these are the floors, these are the offices at that floor, and so on and so forth. And after that, you can review the data in a real time. This can be, of course, from the individual points of metering, as well as you can do that from on the top of the groups. So like I'm interested in how much power we need at the moment for a particular floor or the office, and so on and so forth. So within the user interface, we do have an environment where you can review also the historical data. And even when I mentioned that the key factor of a MeriTO technology is the granularity, here we are using the granular data, like the second or sub-second data, just for the purpose of automatic recognition. But from the perspective of historical data, it is usually enough to have a 1 minute averages or hour averages. You can, of course, go into a detail and review what exactly happened at a particular moment of your interest. From a perspective of analytical tools, the bigger institutions used to monitor the maximums in 15 minutes, of course, maybe the hour averages and overall consumption split into, for example, weeks or the months. I already said that this is kind of a special device which allows for recognition of the equipment. And with that, you can monitor the operation. So for example, when the fridge was turning on and turning off a compression engine, or moreover, if there is maybe a problem linked to that, so it remained on and has not been turned off, or maybe I left the doors open on a kitchen fridge, and so on and so forth. So this is what you can monitor from recognition of individual devices. And of course, you can mark that down, for example, into a profile, power profile, where you can indicate when actually at the particular moment the device was turned on, or later on it finished its operation, like, I don't know, the washing machine, for example. At the end, we are having also an integration, or the possibility to integrate with the third-party systems. We are providing an APIs in order to use the real-time data as well as the historical data for the further processing. Here, for example, one of the great examples, and you can see that, by the way, in University Science Park at Technikum Košice. So you are very welcome if you want to see that in a real action. And there's augmented reality, for example, which is showing you while you are walking over the floor, what is the actual consumption of every single office on the floor. So that's like an integration with this particular technology. Let me tell you a little bit more about how it is built. So what's the structure behind and how we are providing this architecture. There are 4 pillars, and it's an access layer starting from the bottom, then the secure transport layer, the cloud processing layer, and finally an application layer. At the lowest level, there's an access from a MeriTO base, which is like a base device to meter the data and to provide the granularity of measured parameters. So it is exporting that every second or less than second to the cloud. And there is a secondary device at the bottom layer called MeriTO controller, which allows you to utilize the data provided and do some action. So for example, if I'm running out of the profile, I can turn off something which is not really important at that moment. Or as I already mentioned, for example, if it is linked with the solar panels, you can, for example, turn on something based on rules for utilization of the energy. Then we are having a secure transport layer, which is like an entry point somewhere to the cloud. And therefore, we are using a load balancer for the purpose of loading the balance, of course, or balancing the load for multiple devices. We are having here a message broker, which collects the data, and then some device orchestration. As I already said, our professional background is mostly in a computer networking, so all of the security features at the background are incorporated in a product. So it is changing some security tokens in order to securely deliver the data to the cloud, as well as later on to allow the users to access them. Then we are having a third layer, which is a cloud processing layer. Here we are having some data processing middleware, which is basically software which is doing some pre-processing of the data. For example, doing 1 minute averages, hour averages, and so on and so forth. And those are stored in a data storage. Later on, from a data storage, they are accessible through the different backend services. And that's like, again, entry point for an application layer. In an application layer, we are using different data analytics tools. So those are, for example, monitoring the maximum reserve capacity and notifying the customer in case of crossing the threshold and so on and so forth. We are having an automated reporting and visualization. So this goes through different channels, like you are receiving the notification over the email, over the SMS, over the WebEx Teams, and so on and so forth. And of course, some user interface, which allows you to review all of those meter data in a basically real time. Again, from a technical perspective, if we are planning the installation somewhere, we are using a passive transformers. We used to use the YHDC transformers. So there is a strong portfolio of the product available, of a different rated inputs, of a different wire diameters. But usually we are going from 25 amps up to 600 amps. And if we need to monitor maybe higher currents, then we are using Rogowski coils, and those goes up to 1,500 amperes. Let me tell you maybe a little bit more about also about the recognition of the equipment and how we are processing the data in a cloud. So we are coming a little bit more into a machine learning. As I already mentioned, we are exporting something about the 20 samples per second into a cloud for data analytics. So this allows us to identify the rising shapes and the falling shapes of every single equipment which we are turning on or turning off. On the background, we are typically doing 12,000 samples per second, like normal smart meters. Due to the sub-second data which we are having, the rising and the falling edges allows us to effectively recognize some of the equipment which is operated in your building. And the final thing which we are using is the PQ map, which is basically a map taking the data from active and a reactive power of a particular equipment. And you would see that a little later on how we are using that for grouping purposes. So as I already mentioned, we are capturing the 20 samples per second, which are in a cloud for data analytics. And here, for example, on this particular chart, you can see a couple of devices being recognized in a building, or that's particular from my household, for example. And some of the devices are turned on or turned off in a less than second. And that was also the key factor why we went to sub-second data, which we are providing. So once we are having rising shapes and the falling shapes, with that, we can effectively recognize the operation and the startup or turn off of the equipment. From a perspective of a PQ map, you can easily see that every single equipment is having its specific parameters, like what is the active power and the reactive power. And you can group multiple stages at the same group, right? So here, for example, you see that all of those green dots was the single equipment, just changing a little the active or reactive power. At the end, our goal is to do a cloud-based data analytics with the AI algorithms, right? So we are trying to recognize the equipment, mark it down in a chart, like when it has been turned on or turned off. We are able to provide you with a recommendation or a tip what kind of equipment it is. It is the load of, I don't know, for example, the compression engine, or it behaves like a bulb or whatever else. So then you will need to name it, what kind of equipment it is. At the end, we learn also how your devices behave in time. And due to the fact that we see multiple activities inside of a single equipment in a very detailed manner, then we see also, for example, the washing machine in its details, like it is heating, it is twisting, it is filling in the water or putting it out or whatever. But from a perspective of a customer, you would be maybe looking for information about this was the washing machine. So with that, our granularity goes much deeper than the state of a maybe on-off single equipment. And with that, we are applying also the grouping algorithms, which are trying to find the patterns of or sequence of a similar activities and then grouping that back together. So we would be able to tell you this was the washing machine, even when it is heating, twisting, and filling in the water. At the end, what you would like to see is very likely a chart when we will split down the whole energy consumption of a managed object into a particular equipment. Here you see, for example, that everything is unknown, but it is up to the user to define what those unknowns are. Of course, you will need to maybe turn it on, see the notification, and then write down, okay, this was a heating kettle or whatever else. At the moment when you are able to recognize when the device was turned on or when it finished its operation, you can focus on the abnormal activity detection. So that's also one of the part of our product, MeriTO anomaly detection. And here we are focusing, for example, on a duration. So if the device was operated longer than normally, or it was kind of a very short activity, even when normally it is being on for a couple of minutes. And with that, we can notify you about falling equipment like the compression engine or whatever else is behaving abnormally from a perspective of a duration of its operation. Of course, we are watching also the occurrence over the given period. So for example, we are monitoring when you are using the particular device over the day, over the week, over the month, or over the year. Those green dots, for example, here represent the normal behavior. So you will put the system into a learning state. We'll do a normal actions. And then you are watching to anomalies. And the red dots indicates them. So once they will appear somewhere, we can notify again the user that there is something wrong with that particular device, or there is an anomaly from a perspective of a duration, the operation in a day, week, month, or year. And one of the things which might be usable is also the missing activity. So for example, the machine should be turned on automatically, but it didn't happen. So there is some fault in that. Okay, so I shared with you a lot of things from the inside, like how it is operated. At the end, let me just wrap up maybe where the product is usable. So we are focusing on 3 areas. Of course, the facility management, what I already mentioned. So whoever needs to know how its environment is behaving. And therefore, here we are hitting the manufacturing, the governmental organizations, and the city buildings, as well as grocery stores. The second part, which we are focusing on, and there is a separate track on that, is in education. So we have a couple of secondary vocational schools which are learning on how to use the APIs and then to post-process the data in order to better understand the value of the energy they are consuming at the school. And finally, also the residential customers. So these are the 3 segments where we are focusing on. Okay, so that's it about the MeriTO technology, the technology that supports the monitoring and the power consumption analytics in a real time. I'm very thankful for this opportunity. Let me thank you also for watching to this presentation. And if you will have any questions, I'll be glad to answer them. Feel free to reach us at info@celabs.com. Thank you.
Before I'm going to introduce our new speakers, I have to say hello, guys, to Germany, because both of them are based in Germany. And now it's the time to introduce Mr. Igor Ginsburg and Mark Schoppel from Traco Electronics AG, with very interesting topic, which is, to be honest, close to my heart. What limits every power supply? Igor works as an area sales manager, and Mark works as a customized power supply engineer. Traco Power is a Swiss company based in Bar with more than 30 years experience in the field of manufacturing high-quality DC-DC and AC-DC adapters. AC-DC is not the band, it's all about electronics, and it will be about electronics, guys. Before we start, let me ask you a question. Are topics, power supply, and losses frequently asked questions by your customers?
Absolutely. Every customer has to handle the heat dissipation of the power supply and of this application. And it's a crucial part of his design to cool it and to provide a reliable and efficient power solution.
Good morning, everybody. Today we would like to introduce our company. The name of our company is Traco Power. The company was founded in 1944 in Switzerland. We have more than 140 employees all over the world. This is our headquarters in Bar, Switzerland. And you can recognize talks there. It means our products are available even today. We have two subsidiaries all over the world. The biggest subsidiary is in Germany. We have also a subsidiary in France. We have the center in Ireland. We have some subsidiaries in North America, and we have some production subsidiaries in Japan, Taiwan, and Thailand. Also, you can recognize the green points. These are our trusted distribution partners. You can buy our products all over the world. You just contact our partners and you will get everything just in time. Okay, who we are? We were already introduced, but probably once again, Mark Schroppel, my colleague. This is our god of customized solution. He is from Germany, he's married, has one child. He's 3 years at Traco, has 10 years power supply experience, and was Fug. My name is Fug. I'm area sales manager. I am responsible for happiness and entertainment. I am from Germany too. I can speak German, Ukrainian, and Russian languages. This is why I can understand Slovensko too. I am a little bit more than 1 year at Traco Power. I have 10 years experience in international sales and in industry, and my previous employee was Phoenix Contact. So what are our focuses? If we are talking about Traco Power, sure we have some focuses. And our focuses are industry and automation, energy, transportation and railway, medical health care, home building automation, and IT. For example, if we will talk about some toys, probably we will be not the first choice for you, but it depends on the toy. And at the same time, if we are talking about avionics and defense industry, we don't have any dual-use products in our portfolio, our official statement. But we can offer our products from 1 to 40 kilowatt. If you're talking about 1 watt, it's DC-DC products. And if you're talking about 40 kilowatt products, these are customized. So, well, and where can you find our products, or where can you use our? You have your own device, and as you already know, you have AC-DC part, 230 volt AC. It's not so healthy for human beings and also for electronic devices inside of your end product. This is why we can offer AC part to convert 230 volt AC into, for example, 24 volt DC. And for sure, we're a trusted partner in the area. We have different DC-DC converters, isolated, non-isolated, encapsulated, through hole component, SMD component, or even mount chase components, everything for you. You only ask us and you can get the whole power supply offer from one hand. And don't forget our focuses. If we will start with our focuses, we will start with industry solutions. In this case, we can offer you DC converters from 1 up to 300 power supplies from 2 up to 1,000 certifications. We're talking about industrial certification, we're talking about 1,000 with different mounting types. For example, we have some components, basic mount components, and also rail components. Offer you case 3 years warranty. How it is split, if we are talking about HVDC components for industry, we are talking about encapsulated, open frame, metal enclosure, outdoor switching, and DIN rail power supplies, and if we are talking about DCDC, about SMD components, about SIP components, DIP components, test assembly, DIN rail models, and also very important, industrial high power solutions. The next step, this is our medical focus. For medical industry, we have DC converters with wide input range. We have AC power supplies up to 800 watt. We have different certifications for this product. So, for example, if we are talking about special for medical industry, we are talking about 60601 third edition with 2 MOPP isolation. And in this case, we can offer you 5 years product warranty. Our products are split in 2 HDD area. We have encapsulated, open frame, and metal enclosure solution. And in the area, we have SM, SI, and DIP components for your medical products. My personal favorite is railway. This is my favorite and one of the biggest focuses by Traco Power. We have these converters, wide and ultra-wide input range. We have 8 power supplies for railway, and also we have rail for non-rolling stock. We have special certification for railway, it's 105, and for these products, we can offer you 3 years product warranty. We're talking about railway, this are SIDA products, off-board products, and also can offer search filter accessory. And we are looking forward. This is why we have a portfolio for home building automation, ACD, and these ACD products as well. We have encapsulated, open frame, and rail power supplies with low power. And if you will not find any suitable product for your application, you can contact us and we will find a solution, especially for your application. I'm talking about customer solution. And what is our highlights for this year? We have some very nice highlights for this year. First case, so the first slide, this is power supply here with power function up 140% with reinforced insulation, isolation up to 3008. The operating temperature range is from -40 up to 85%, up to 85 grad Celsius. With low power use, comfort air directive. It was certified for IoT and home automation with integrated filter inside and with 3 years product. The second highlight is TPP 1465 series. It's a power supply for medical application, high isolation, 4000 volt isolation. The PCB and cases mount module encapsulated with low leakage current, because you can, in this case, you can use the end device directly on your body with operating temperature from -40 up to 80 grad Celsius with special certification, the 4th edition European medical operating up to 5,000 and with 5 years warranty. And the next highlight, I have slides here, but unfortunately we don't have enough time today. This is why I will try to find this. We have TI 100, we have TI 300 and TI 300. 180 means 180 watt and 300 means 300 watt. Was developed for medical applications, high installation, special medical certification, and with 2M isolation side, with peak power operation up to 220 watt. We are talking about 180 series. With operating temperature from -40 up to 85 grad degree, and with, very important, with power factor correction, as a 0.9. We are offering for the product 5 years warranty. This is the singular product, but with 300 watt, and the peak power operation is 360 watt in this case. And the next highlight for this M60 VI series, VI means wide range. TFM was developed for medical, has 60 watt power, has high isolation, 5,000 watt AC because it is for medical issues, has 2 MWP installation, low leakage, because you can use this directly on your body. The end device can be used directly on your body, and with 5 years warranty. The next highlight, this is my personal small highlight, PS 15 series. We have different types from 3 watt up to 15 watt, developed for automation applications and IT. This product has special certification for this. Is ready, low power losses, fully encapsulated, has integrated EMI filter inside, has reinforced isolation to 3,000 AC, and we will offer in this case 3 years warranty. So let's look on our railway highlights. The first railway highlight is TEN series. Different versions from 3 watt up to 40 watt, with special certification for railway, internal EMI filter, from -40 grad degree up to 95 grad Celsius. You will not have any derate. You have some nice integrated functions inside, on off, over temperature protection, over voltage protection, and for this component, I can offer you 3 years warranty. My personal highlight is T. In this case, we are talking about T100 IR series, ultra wide voltage range from 9 up to 75 and from 14 up to 160. The special certification for railway, encapsulated with extended hot uptime. The temperature range from -40 up to 85 grad Celsius. Has high isolation and has a lot of functions inside, for example, remote on, off, and trim function, short circuit protection, over voltage protection, over temperature protection, everything what will be required in your application. And for this product, we can offer yes product warranty. The next step of our presentation is explanation. What can be promised and what is our personal DNA? You know our motto: reliable, available. Now we are reliable. Traco power products, many high critical applications. We can offer you 3 or 5 years product warranty, and we keep our promise. If we will promise you something, we will keep our word. we are available. Don't forget, I showed you our stock in Switzerland. It's huge, and we have more than 25 million US dollar on our stock. We have more than 5,000 products on our stock, and all these products are available. You can order our products, and you will get suitable lead times, and you will get our products just in time, as discussed. And for sure, now we have experienced engineers in our team, we have experts in our team, we have fast and flexible organization to support you, and we are ready to give you our support and to give you our know-how. Our tech support is great, and you can write us an email, and you can also call us, and we will help you to design our product, your applications. So where can you find a little bit more information about our company and about our products? You can visit our homepage, for example, in search engine, you can find a searchable Traco Power product for your. You can compare our products. You can download data sheets. You can take the product lifetime status. Is it already on well, or this product is recommended for new design. You can find the simplest areas if the product was already. You can find a compatible accessories and application notes. You can download 3D drawings, files, and pinning files to integrate our products in your application. And if you will not find a required information on our homepage, you can contact us. We have a contact data on our homepage. You can write an email, and we will answer it as soon as possible. On this point, I would like to give word to my colleague, Mr. Topel, and he will explain why should you buy our products, what is important, and why are the power losses so important in your applications.
Thank you, Igor. So we are talking about thermal limitations and the question, what limits every power supply? In today's content, we have 4 main topics. We will talk about the reasons why every power supply is limited by thermal aspects, and we will talk about efficient usage of your power supply. Then we will name the top 5 components which will limit your power supply's life and the maximum temperatures in your application. Third topic is to get a better understanding about the usage of your power supply. We will talk about practical examples, and we will talk about some differences of components, because some components should keep as cool as possible, and for some components, that's also an interesting aspect, it's not so critical and they can become a little bit warmer. Finally, we will sum everything up together, and I would like that you learn something and that you have some consolidated takeaway messages for you. We will start with our limit lines. You will know from our data sheets. We have input voltages with some deratings, and we have temperature deratings at high ambient temperatures. In this example, we have the TIB series, here the TIB 480. And when we talk about the input voltage first, why are we lowering the maximum output current at low input voltage? So the main reason is a thermal aspect as well, because the input stage is getting warm. So the reason for that is the current increases to keep up the same output power. And due to the thermal aspects of higher power losses, this is the higher power losses, I square multiplied with the resistance of all the components, this power losses are increasing and get to a critical level, and that's why we can't go over a certain limit. At the same time, there are thermal aspects for the ambient temperature. And above 60 degrees of ambient temperature, we are not allowed to take the full output current, and that's why we have to decrease it slightly. And here is at the same time as a dashed line a very interesting point. The maximum allowable output current is plus 50% of boost. And why is there a capability of 50% boost? You can ask, and the reason for that is that we have to make a difference between thermal aspects and electrical capability of your output power. And this difference is important to understand, because the electrical capability is always higher than the thermal capability of your power supply. And the reasons for that are in the design of the power supply, and it's not only valid for Traco power supplies, it's valid in general for nearly all power supplies on the market. To talk about the backgrounds about this reason is you need a little bit a better understanding of one of the main components. And one of the main components is the transformer in the power supply. So what is driving the size of this transformer? You need minimum creep pitches and clearance distances to provide the isolation. You need a minimum cross section for winding to bring the turns, the number of turns in this bobbin. And you need a minimum size for thermal power dissipation. And the first two topics are dominating. These first two topics are providing you the minimum size, and the thermal dissipation is a minor topic. And that's why the electrical power is always higher than the thermal capability of the transformer. And this is the key. Here you can see the magnetization curves of the transformer. And on the green dot, we are usually working. So we have a nice efficiency. The power losses are not at the peak, so we have kind of a sweet spot. But we can go up to the red dot for a certain time of seconds until we get too hot. And in this time, in this example, it's 5 seconds, you can get plus 50% of, let's call it bonus power, for free, for example, motor starting applications or for charging a capacitor bank at initial startup. And this is possible with a certain duty cycle, not every millisecond again, but in average, it's possible to get from time to time some peak power. So, and one of the key aspects what is important to understand is that we try to work in a sweet spot to generate the maximum efficiency. And this sweet spot is always below the maximum power capability of the power supply. Next topic, besides of the transformer, is the power MOSFET for switching applications. Here it's a similar topic. We are normally using this power MOSFET in as cool applications as possible, but the power losses will increase when this power MOSFET is getting hotter. And the reason for that is the RDS on, is the channel resistance of this silicone power MOSFET. And this resistance is increasing dramatically with the temperature. So it's a positive temperature coefficient behavior. And this coefficient is almost double when you increase the temperature by 100 Kelvin. And this is dramatic because it's a self-reinforcing aspect. And the higher the losses, the higher, the higher the temperature, the higher the losses. And that's why it's critical for your power MOSFET to keep him as cool as possible. At modern technologies, we have gallium nitride and silicon carbide MOSFETs as well. And when you compare it to classical silicone MOSFET, the behavior is very similar. This slide I call some like a tot, for example, the transformer. It's not such a critical component for maximum ambient temperature, because the efficiency curves you can see for this ferrite powder ferrites, the most efficient points can be at 140 degree. And usually we're using this high temperature power ferrite because we know our customers will go to some high temperature applications usually. And for example, the 3C95 core material has a minimum at 140. And that's why the sweet spot is when we allow the transformer becoming warmer. Of course, there are also some limitations like this isolation foil. We can go up to class F isolation foil. That's usually the highest allowable class with 145 degrees maximum allowable temperature. And then we are working in kind of a sweet spot. To keep some margin, I would recommend 120 up to 130 degree. And you can measure this in your application when you have an open frame power supply. It's not a secret. We will provide you the maximum numbers for your power supply. And then you can measure in your application what is the temperature of the transformer, for example. And then you can optimize it in your design. There are further components which you can allow to become a little bit warmer. For example, it's the input rectifier. The reason for that, you can see here again into the two working points, the green working point and the red one. And you can see when the temperature is increasing, the forward voltage drop is decreasing. That's why it's more efficient if the rectifier is getting warmer because the power losses are becoming reduced. And in this example, we are talking about 17% less power losses for this voltage rectifier. Second example is the reverse polarity protection diode. If you don't switch this diode and you are not dependent of the leakage current of this diode, it's a nice behavior if you bring this temperature to a higher level. And by experience, we can say it's very rare that a diode or a bridge rectifier is failing its application. There is not a big fear about this very robust component. Third component, which you can bring to a higher temperature without big risk, is the inrush current limiter, the thermistor NTC. At startup, you want that this resistance is higher to prevent a high inrush current, but in the later application, you want this resistor as small as possible because to avoid the power losses. And we can see that this resistor is always generating losses in your later application, and that's why it's not a clever idea to cool it too much, because then you have higher losses. For example, here are some applications from competitors, of course, and the standard USB power supply here. When the resistor is very, very low, then you have incredibly high inrush currents. And I tested it personally in my home. Every time I put this power supply in the wall socket, I get a spark because the inrush current limitation is so low, and you always get a peak of 50, 60 amp. And you can see it here on the connection points. It's getting burned after just 2 weeks of usage right now. So we come to the next question, and it's how to cool your power supply. And there are 3 main aspects of the power supply cooling. The first one is conductive cooling. That's, I would say, a market trend. The second one everybody knows is the convection cooling. Then we have radiation, and this thermal infrared radiation is usually heavily underestimated. Everybody is forgetting it from my perspective. And that's a little pity because it matters. And you can get a few percentage of the power losses for free out of your box just by radiation. Convection, it's clear it can be also forced convection, and it's significantly getting better the cooling capability if you have a small fan and a forced air cooling capability. I understand that a lot of customers don't want it because the fan is a mechanical part and it can fail and it's generating some noise. But later we will have an example how efficient it can be. Let's talk about the thermal radiation and why it's so heavily underestimated. Here we have the example of the TPP 100 watt power supply. For simplicity, it's 100 watts of output power and 8 watts of power losses. The radiation is calculated by the surface of this power supply. Here I calculated the efficient the surface of this power supply, and it's 180 square centimeter. When you calculate it width multiplied by height multiplied by the length, and you are considering 5 of the 6 sides. Then we can say, and we assume, that it's a black anodized surface, because then the infrared radiation is most efficient. And by this formula, you can see that the ambient temperature is going up with the power of 4 in this formula. Sigma is a constant, and the surface we have calculated. And when we put all these numbers in the formula, we can see that at 75 degrees of surface temperature, we have an infrared radiation of 15 watts. Moment, 15 watts, but we have just 8 watts of power losses. How can that be? The reason for that is we can radiate in infrared with 15 watts, but the room is answering. You are not in the free space, and we get 12.5 watts back from your environment. Let's say the environment is, or your enclosed cabinet has 60 degrees Celsius, then you can radiate 15 watts, but you get 12.5 watts back. That's not perfect, but it's still a win of 2.5 watts in pure radiation. And when we are considering this 2.5 watts and put it in relation to the 8 watts of power losses, we gained 31% of the power dissipation by purely radiation. So we don't have to talk about convection cooling or conduction cooling. It's through the air, and it's gone. And that's a nice matter from my approach. So active cooling, we need to talk about the remaining 70 watts to get rid of them. And in active cooling, we have to consider the side for the airflow. And here it's important to know which components need to be cool and which components need to be hot, or we can allow to be hot. And here in this heat map, I painted for you the components in blue and red. Blue for the components which should stay as cool as possible. The electrolytic capacitors, for example, the MOSFETs for efficient power losses. And the hot components, here it's a rectifier. Below here is the NTC for inrush limitations. And here it's a transformer. And these components are more efficient when they get warmer. And then we have a heat map, and you can see here a cross section. And I would recommend, if it's possible, to blow through this blue angle to cool this at first the electrolytic components, because they are dominating in the lifetime of your power supply. A second component, which I didn't mention yet, it's the optocoupler. It's usually sitting on the bottom side. It's also dominating the lifetime, but it's the optocoupler isn't generating losses. That's why he's usually cool. But the remaining components are generating power losses by their own, and that's why it's a good idea to cool them in an active way. And if we do that here in this example, we can see in this thermal pictures how the temperature is decreasing. And here it's really a very small fan. It's not loud, and it's 12 volt DC, and you can even undervolt this fan. And it's still making so much cooling capability, because here are the correction curves for the fan speed in meter per second. And the red point, it's not a forced air airspeed, it's a convection airspeed. 0.5 meter per second you have when you have convection cooling. If you increase this airspeed with a very small fan with very small noise, you can see even at 1.5 meter per second, you have a significant correction factor for the thermal resistance. And this is making so much effect that's very recommendable to use small fans in your application and to control them with a temperature, that they are very silent, but that they have the capability to go up when the output power is needed. Due into my researches, I also found very rare discussed factors for the thermal considerations. The first one we should talk about, what is about humidity in the air? You could think about the more humidity in the air is, the better the cooling capability. So it's a nice question from my perspective, and I took a lot of research to answer it. And here is the answer. The thermal capability of dry air and the thermal capability of 100% saturated humid air, it's not a big difference. So it's completely neglectable. There is just 2.5% difference in the thermal capability. And when you see here in this formula, it doesn't matter. You can forget about it. But it's nice to know for the future. It's not a big difference. What makes a huge difference is the altitude. That's why you have always to consider the altitude in your application. And the question is, where are you testing? And what's the maximum altitude from your specification? And here I can tell you, most supplier will provide you the information at close to the sea level. And this has a practical approach because most of the people are living at a lower altitude. Even Munich, it's just on 500 meters of altitude. We are developing a lot of power supplies in Ireland. That's also very low sea level. And let's go up to a higher altitude and let's see what is happening with the pressure of the air. And we can see from 0 meter altitude going up to 5,000 meters for medical applications, we have a loss of 45% in the thermal capability of this row in this formula. And this means the delta T of your application will become higher. And that's not a good news compared to your sea level application. You will get a significantly higher temperature when you don't consider this. It's very hard to test. I could see a lot of customers are simulating this or calculating this even for the certification. And that's a valid aspect. You can do this. Practical tests, you would need a pressure chamber. And usually it's not part of your test design. But with this correction curves, you can calculate it quite linear and that's valid and it's accepted by the certification agency. So the message is, please take care about the altitude. It's crucial for your design. Also, I want to give you by hand a rule of thumb for free convection. I usually make this quick estimation when a customer is coming to me and he's talking to me, look, my power supply is getting too hot. And I make a quick estimation about what would I expect about the temperature increase. So I calculate the outer surface. It's again the same example with 180 square centimeter. And I need the power losses. And with this formula, you get the thermal resistance from the surface of your power supply into the air. And this is easy to estimate. It's 1 Kelvin by 1 square centimeter divided by the power losses in milliwatt. And this linear approach is quite easily to calculate. So we have 8 watts of power losses, and the surface temperature is known. So we have 44 Kelvin of temperature increase. And this is a very good estimation, because in a 20-degree environmental at home or in your laboratory, you can expect that this outer temperature of the power supply will go up to 64 degrees. And I haven't tested it so far, but I would expect plus minus 5 Kelvin. That's the expected range. Okay, then let's wrap up what we have talked about. Takeaway messages for you. The first one is the semiconductors are limiting your power supply, and you have to keep them as cool as possible. The transformer is limiting your power supply in the mean of thermal aspects, but there is a high capability of electrical margin, and you can use it with the boost power. And it's not so critical to cool the transformer and inductive components, because they are getting more efficient the hotter they become. The lifetime is dominated in your power supply by the electrolytic capacitors. You should try to keep them as cool as possible, and also have in mind about the quantity of the components. Quite often there are a higher number of electrolytic capacitors in a capacitor bank, and then you have 5 or 6 components at once, and then it's in your MTBF lifetime calculation, it's getting even more critical. Then have in mind, that's one really important message for me, allow your power supply to radiate. Don't pack it too close, let the radiation shine and let it get out into the room. You get free cooling with this radiation capability. And have in mind, maybe you can talk to us when you have a very high power design in your application, how to cool the power supply, and then we can talk about which components you should keep as cool as possible, because we are the designer and we are knowing which components are critical and which ones are not critical. And at last, consider the altitudes in your cooling design, because it really matters. The effect is, as we have seen, is going up to 50%, and that's really important not to fail in high altitude. So I want to thank you for your attention, and if there are questions, please let us know.
Feciľak Tamás vagyok, 2015 óta folyamatmérnök az Elektronika Kft-nél. Cégünk 2019 óta rendelkezik röntgengéppel. A röntgenvizsgálatot ma már az élet számos területén alkalmazzuk, a gyógyászattól a régészeten keresztül az ipari anyagvizsgálatokig. Mi azonban elsősorban optikailag nem látható forraszkötések vizsgálatához használjuk. Napjainkban egyre inkább elterjedőben vannak azok az alkatrészek, tokformák, amelyek alsó kivezetéssel rendelkeznek, és ezeket hagyományos módszerekkel, mint például az EOI, nem tudjuk ellenőrizni. Ilyen esetben tud nagyon jó szolgálatot tenni a röntgengép. Jellemzően a BGA, LGA és QFN alkatrészeket szoktuk mintavételesen vagy 100%-ban ellenőrizni röntgenberendezéssel. Természetesen a röntgengép csak egy eszköz. Ahhoz, hogy a forraszkötések jóságát meg tudjuk ítélni, megfelelő forrasztási, alkatrészgyártás technológiai ismeretek is szükségesek. Olyan ez, mint amikor egy ultrahang felvételen egy kismama vagy az apuka csak a fejlődő kisbabát látja, de egy gyakorlatorvosi szám észreveszi az esetleges fejlődési eltéréseket, mivel tudja, hogy mit kell látnia egy ilyen modern képalkotó rendszeren.
Thank you very much for the presentation. We are going really international, so I can easily say see ya. And with these words, I'm introducing Mr. Peter Bátorfi from Inteliport with another very good and very interesting topic dedicated to IoT explosion, specifically NB-IoT and LTE-M technologies in practice. Peter has been the CEO of Inteliport Solution since 2008, so I would say very important person for us today to present. Industrial digitalization has been in a full swing because it's very important. This is why the introduction of low power wide area network, LPWAN, and I think Peter will elaborate further, it's a topic of today, and he will introduce. But prior moving further, let me ask you a question. When have you decided to invest and work and dedicate yourself to this type of technologies?
Okay, it all began in 2016, I guess. So it's already 6 years ago when I got a preliminary data sheet of a new cellular module supporting NB-IoT technology. At that time, I've heard about this technology, but I hardly know anything about that. And just seeing this data sheet and getting some information of that, I saw that it was a bit too nice to be true, you know. So I cannot resist to cross-check the truth of that, and our curiosity and the innovation way of thinking made us to check it. So for the first we made a development kit, or so-called test bed for that, and with one of our mobile operator partners we started testing this technology. Actually, the first NB-IoT base station in Hungary was operated in our office due to the good relationship with this mobile communication provider company. So the tests began, and a year later we created the first test samples of our first NB-IoT product, which was a parking sensor. And another year later, the first sensors were installed in a production real-life environment, and we started this business line that time. And from that, it evolved a lot, of course, but this was the very beginning of this story.
Very good, very good. I like it. So it sounds as a very good decision, right?
Yeah.
Thank you.
Nagy szeretettel köszöntök mindenkit. Bátorfi Péter vagyok, az Inteliport ügyvezetője, és nagy megtiszteltetés részt venni az eseményen. Köszönöm a szervezőknek a meghívást. A téma, amit választottam, az a IoT Boom címet kapta, tehát az IoT technológiáknak és az IoT megoldásoknak, alkalmazásoknak egy berobbanása, amit évek óta jósoltak a szakértők. Ma már látjuk, hogy ez meg is történt, és ez már az a folyamat, amiben benne vagyunk, úgyhogy most már még pontosabban látjuk előre a jövőt, úgy gondolom. Aki esetleg még nem tudta, hogy kit hibáztassa, amiatt, hogy az úgynevezett chipválság ránk tett, hát az egyik dolog, amit lehet hibáztatni, ami persze nem teljesen jogos, az, hogy az IoT boom beindult, és igazából az egész iparágban egy akkora keresletet ébresztett, ami így a Covid-járvánnyal karöltve egy rossz időzítésnek köszönhetően most ezt a hiányt okozza, de minden esetre egy kézzelfogható bizonyíték annak, hogy ezek a jóslatok ezek beváltak, és ezek a típusú megoldások ezek valóban egy robbanásszerű terjedésnek indultak. Természetesen az IoT-nak nagyon sok ága boga van. Én most két olyan technológiát emeltem ki, a Narrowband IoT és az LTE-M technológiákat, amelyeket mi a legfontosabbnak tartjuk, és a legerősebb hajtóerőt ebben látjuk, vagy a legerősebb megalapozását annak, hogy ezek az IoT alkalmazások tényleg betöltsék azt a szerepüket, amit várunk tőlük. Mik is igazából ezek a hajtóerők, és miért is van szükség az IoT-re? Anélkül, hogy nagyon belemennék a mélyre, mert úgy gondolom, hogy az IoT az most már az elmúlt években egy annyira közismert fogalommá vált, és akár tudatosult mindenki, akár nem, de már a mindennapjaink részévé vált, hogy igazából nem is az IoT, hanem annak a terjedése és ennek a sebessége és a miensége az, ami érdekes, és hogy mik ennek a hajtóerei, és mik azok, amik ezt lehetővé teszik. Úgy gondolom, hogy minden új technológia, ez is először ott indul el, vagy ott képes elindulni és meggyökerezni, ahol azért a legkritikusabb problémák vannak, tehát ahol a legnagyobb szükség lehet ezekre. Én itt mondanék is egy példát a saját gyakorlatunkból. Az egyik első ilyen IoT megoldás, még nem ezekkel a LPWA technológiákkal, vagy korábbival, de IoT, az a közutak mentén ez az útmeteorológiai megoldás, aminek a fejlesztésében részt vettünk, és az IoT részét azt a mi cégünk fejlesztette és gyártotta. Ez nagyjából arról szólt, hogy az utak mellett voltak mindenféle szenzorok, és az utak lefagyását egy fél-egy órával előre tudtuk jelezni, vagy mai napig is előre tudja jelezni a rendszer, tehát van idő a jégmentesítésre miatt balesetet okozni. Ez egy jó példája a kritikus alkalmazásoknak, mert ezek tényleg életet tudnak menteni. Tehát abban az időben, ez jó régen volt már, kb. 10 éve lehet, ha jól emlékszem, nyilván még nem azok sokkal magasabb költségekkel, mindenféle technológiai limitációkkal, de ez el tudott indulni, és akkor egy nagyon jó megoldás volt. Ahogy fejlődött tovább, nőttek az ügyféligények, nőtt a hálózati lefedettség, a hálózati képességek, jöttek újabb termékek, és ami nagyon fontos, hogy mind a beruházási, mind az üzemeltetési költségek elkezdtek csökkenni, ezek az IoT megoldások terjedésnek indultak. Nagyjából ez az IoT piramis is ezt jelenti, hogy jövünk lejjebb a piramisba, először mission kritike, utána az üzleti kritikus, majd tulajdonképpen most már belépőben vagyunk abban az időszakban, amikor már szinte minden eszközünk valamilyen IoT megoldás részévé válik. Az üzlet kritikusra is tudok egy szemléletes példát mondani a saját gyakorlatunkból. A John Deere talán ismerős ez a márka, ezek ilyen nagy gépeket gyártanak a kombájnoktól a traktorokig. Svédországban hatalmas erdőségek vannak, itt a John Deere-nek a fakitermelő gépeit használják elsősorban. ilyen ezres nagyságrendben kell ezekre gondolni, és ezeknek van egy távfelügyeleti rendszere, ami a proaktív maintenance teszi lehetővé, és ez is a mi IoT megoldásunkat használja. Ez tipikus egy olyan megoldás, ami életeket nem ment, lássuk be, viszont üzletileg egy nagyon jó megtérülést mutat, mert ennek segítségével idő előtt lehet tudomást szerezni arról, hogy meg lehet pontosan jósolni, hogy mikor lesz karbantartásra szükség. Sokkal olcsóbban lehet megelőző karbantartást végezni, mint akkor tüzet oltani, amikor elakad egy ilyen gép valami erdőség közepén. Ha megyünk tovább ezen a háromszögön, vagy ezen a piramissal, akkor jönnek azok a megoldások, amik már nem is feltétlenül üzletileg jól kimutatható hasznot hoznak, de egyszerűen könnyebbé, kellemesebbé teszik az életet, fenntarthatóbbá teszik a környezetünket. Például azok a parkoló szenzorok, amiket mi fejlesztünk és gyártunk, azt én körülbelül ebbe a kategóriába sorolom. Nehéz lenne forintba kimutatni, hogy hány forintot spórolunk ezzel meg, de nyilvánvalóan rengeteg bosszúságot, rengeteg környezetszennyezést lehet ezzel redukálni, tehát mégiscsak egy nagyon hasznos megoldásról van szó. Itt a képernyőn azért felsoroltam egy néhányat azok közül, a tipikus IoT alkalmazások közül, főleg az ipari területről, amiket a legfontosabbnak tartok, és amik azt hiszem, hogy talán mindenkinek, hát csak így kiemelgetek dolgokat velük, mondjuk a smart utility, tehát a közműszektornak a megoldásai, az okos hálózatok, okos mérés. Hát ma, amikor egymás után jönnek a hírek az energiaválságról, akkor aztán teljesen egyértelmű, hogy ezek minden olyan megoldás, ami hatékonyabbá teszi ezt a rendszert, az rendkívül hasznos. De hogyha mondjuk alulról indulok ki a környezeti vagy a mezőgazdasági megoldásokból, hát éppen egy élelmiszerválságban vagyunk, és egy klímakatasztrófa felé tartunk, tehát azt hiszem, hogy teljesen egyértelmű, hogy ezek a technológiák és ezek az IoT alkalmazások, ez nem nem akarok cikizni más megoldásokat, de mondjuk nem az a felesleges hülyeség, hogy most akkor a telefonom selfie kamerája hány megapixeles, hanem ezek olyan technológiák és olyan alkalmazási területek, amik valóban kulcsfontosságúak ahhoz, hogy valamennyien élhető, vagy a megszokott életminőség az tartható legyen. Na de hát hogy jönnek ide az RPVL megoldások? Ezeknek itt ahogy látszik, hogy igazából az, hogy ezeknek a beruházás és a fenntartási költsége mennyi, nyilvánvalóan meghatározom. Ahogy ezeket tudjuk lefele nyomni, újabb és újabb megoldási lehetőségek nyílnak meg, újabb területeken lesz ez egy végrehajtható, megtérülő és jól üzemeltethető megoldás. Úgyhogy valójában nem egy ilyen szép, szabályos háromszögről beszélünk, mindez követ egy egyenlőszárú háromszög, hanem a valóság az, hogy ez sokkal szélesebb, és igazából ahogy az üzleti kritikus majd amit tudjunk, ez a mindennek már minden IoT-n lesz, ez nyilván egy hatalmas robbanást jelent mennyiségekben is, de ehhez meg kellene, hogy legyenek alaptechnológiák. És ez az alaptechnológia, amit nagyon régen vártunk, ezek a bizonyos RPVL technológiák, ezeknek nagyon sok válfaja van, én most ebből kettőt ragadtam ki, az MB-IoT, a Narrowband IoT-nak a rövidítése és a CAT-M-et, majd később azt is elmondom, hogy miért ezt a kettőt gondoljuk mi úgy, hogy a legfontosabbak. Amikor azt mondom, hogy itt lesz és ott már folyamatban van egy boom, egy robbanás ezeknek az eszközöknek a használatában, azt így számszerűsíteni is lehet. Ez a táblázat, amit itt látni lehet, itt ez a középső sáv világos, vagy közép lila talán ez a jól megválasztott szín. Ezen éles szeműek azt láthatják, hogy körülbelül a következő 3 évben 2 milliárd új eszköz fog használatba kerülni, csak ezzel a két technológiával. Tehát 3 év alatt 2 milliárd eszköz, ami azt hiszem, hogy egy eléggé döbbenetes szám. Az egyik, ami ezt lehetővé teszi, talán az egyik legfontosabb alapja ennek, azon kívül, hogy ezeket a technológiákat, ezek megszülettek, ezek az alaptechnológiák, az, hogy a hálózati szolgáltatók ezt világszinten bevezették, és mára itt a jobb alul lehet látni a térképet, mondjuk, hogyha Afrikát, mert ugye a fejlődő világot nem, tehát a fejlett világra koncentrálunk, akkor gyakorlatilag az látszik, hogy a világ minden részén, vagy az MBIoT, vagy az RTM, vagy mind a két technológia ma már elérhető. Egyébként Európában teljes mértékben, de látszik, hogy Észak-Dél-Amerika, Ázsia legnagyobb része, Ausztrália, dettó. Tehát a fejlett világban nehéz olyan részt találni, ahol ez a lefedettség nincs meg. Mert nyilván anélkül remek megoldásokat lehet fejleszteni, csak éppen telepíteni és üzemeltetni, nem? Tehát ez egy nagyon fontos előfeltétel, ami az elmúlt pár évnek az eredménye, és ez az, ami berobbantja és felfűti ezt a növekedést, ami már eddig is elindult. A másik, ami ehhez a növekedéshez kell, hogy legyenek megoldások, legyenek olyan termékek, eszközök, meg körérendszerek, amik ezek tényleg kihasználhatók, és ezek az IoT alkalmazások, ezek használható lehetők. Hát itt jön be az Intelliport és a hozzánk hasonló cégeknek a szerepe. Tehát a mi feladatunk és küldetésünk az, hogy ezek alaptechnológia létezik, hálózati lefedettség létezik, akkor nekünk azokat mondjuk mi is speciál ipari IoT-re fókuszálunk, tehát azokat az ipari IoT-ben szükséges eszközöket, és nyilván ezek köré rendszerfelügyeleti, adatgyűjtés, minden egyéb alkalmazásoknak a fejlesztése, gyártása, amivel foglalkozunk, ami ezeknek a tényleges megvalósulásához szükséges. Azáltal, hogy az iparra fókuszálunk, azon kívül, hogy nyilván ezek az eszközök működjenek és a megfelelő funkcionalitást ellássák, nekünk nagyon erős fókuszterületünk a menedzselhetőség és a biztonság. A menedzselhetőség ezeknél a megoldásoknál már nem egy opció, tehát itt azért minden esetben ezres, tízezres, százezres eszközszámokban kell gondolkodni. Nyilvánvalóan egy nagyon jól átgondolt és jól megtervezett központi menedzsment és robosztus eszközök nélkül ezek üzemeltethetetlen, kevadva fulladó megoldások lennének. A másik a security, ami főleg manapság, amikor háború dúl a közelben, és a szakértők szerint a kibertérben ez a háború, ez már sokkal korábban elindult, és mi is, és a legtöbb egyéb ország is érintett benne. A security-nek a szerepe az borzasztóan felértékelődött. Tehát elsődleges prioritás, hogy ezek megfelelő biztonság mellett üzemeltethetők legyenek. A munkánk során nem egyedül vagyunk így az elefántcsontoronyban, hanem nagyon sok gyártóval működünk együtt. Többek között ebben a sorban a legújabb a Cisco, akinek worldwide fejlesztő partnere lettünk, úgyhogy ez most újabb szárnyakat ad, hogy úgy mondjam, és újabb lehetőségeket nyit meg a számunkra is. Térjünk vissza kicsit a technológia alapokhoz. Nyilván most nincs olyan időkeret, meg nem is ez a célja ennek a rendezvénynek, hogy itt nagyon, nagyon mély technikai alapokba belemenjünk, de azért az pár dologra fölhívna a figyelmet. Az egyik legfontosabb, hogy ilyen LPWA, tehát ez a Low Power Wide Area, tehát alacsony fogyasztású, de távoli, vezeték nélküli kommunikációt lehetővé tevő technológiákból sokféle van. Mi azok mellett tettük le a voksunkat, amik úgynevezett ilyen 3GPP szabvány technológiák, vagyis a hagyományos megszokott, kiépített mobil hálózatokon üzemeltethetők. Tehát nincs szükség bázisállomások létesítésére, új hálózat létesítésére, hanem a meglévő hálózatok tulajdonképpen felupgrade-elhetők arra, ez alapvetően szoftveresen, hogy ezeket a technológiákat is támogassák. Nyilván ennek számos előnye van, a legnagyobb az, hogy mivel nem kell hálózatot építeni, ezért nagyon gyorsan és viszonylag alacsony költséggel bele lehet vágni, tehát van számos más előnye is, amiket megszoktunk a mobil hálózatokon, például a biztonsági oldalról, vagy mondjuk egy eSIM megoldás oldalról, az itt minden alap, hogy minden működik, mert ugyanaz az alap 4G-s, 5G-s technológia van alatta. egy szó kitérően a 4G-re, 5G-re, főleg mostanában, amikor a 3G és 2G-s hálózatoknak a lekapcsolásáról sokat hallani, és ez azért sokaknak okoz fejfájást is, de nagyon fontos azt tudni, hogy mind a CATEM, mind az NB-IoT, ezek az 5G-ben is benne vannak. Tehát a 4G-s és 5G-s technológiák egyben, tehát hogyha egyszer valamikor a távoli jövőben a 4G-s hálózatok is kiöregszenek és lekapcsolják őket, ez a CATEM és NB-IoT, ez továbbra is élni fog, mert az 5G-ben ugyanígy benne van, ez nagyon fontos. De hát miben is különbözik, többször utaltam, hogy a hagyományos hálózat, meg a 4G és azon belül ezek a LTV technológiák, azért van pár markáns különbség. Itt egy olyan meghatározást szoktunk tenni, hogy vannak a narrowband, tehát az alacsony sávszélességű 4G és 5G-s technológiák, ezek a bizonyos LTV-ek, és vannak ugye broadband vagy széles sávúak, ezek azok, amiket a telefonunk támogat, meg a hagyományos routerek, és amire azt mondja a hagyományos hálózat. Most miben is különbözik? Itt egy pár legfontosabb szempontot emeltem ki, hogy ezek a narrowband technológiák, amikről most beszélünk, mennyiben jobbak, mennyiben mások, mint a megszokott. A legfontosabb az az érzékenység. Ezek kb. 10-20 decibellel érzékenyebb, nagyobb érzékenységet tesznek lehetővé, mint a szélessávú technológiák. Mit is jelent a 10-20 decibel? Nagyjából ezt úgy kell elképzelni, hogyha mondjuk egy irodaházban van egy normális lefedettség, vagy szóval van valamilyen lefedettség, akkor ezek a narrowband technológiákkal a -2. szinten a garázsban is lesz lefedettség. Vagy ha a kertben van mobil lefedettség, akkor ezekkel a narrowband technológiákkal egy vízakna alján is lesz lefedettség. Tehát kb. Ennyit jelent ez a 10-20 decibel plusz. Ebből is ez a kifejezés, ez a deep coverage, hogy ezek a nehezen elérhető helyeken is lefedettséget lehet biztosítani. A másik legfontosabb tulajdonság az alacsony fogyasztás, ami a nevében is lett benne, az a no power. Itt megint csak ilyen egészen más nagyságrendekre kell gondolni. Tehát nem úgy, amikor naponta kell tölteni a telefonomat, akkor ne úgy képzeljük el, hogy ezeket elég hetente tölteni. Itt olyan megoldások léteznek, nekünk is a napi gyakorlatban most már vannak ilyen megoldásaink, amik elemről 5-10 évig képesek működni. Nyilván más funkcionalitása, mint egy telefon, tehát IoT környezetben és IoT alkalmazásokban, de elemről 5-10 évig. Tehát egészen más nagyságrendekről beszélünk, mint amit hagyományosan megszoktunk a mobil kommunikációtól, és nyilván ezek azok a képességek, amik rengeteg új felhasználási területet nyitnak meg. Nyilván ezeknek a pluszok mellett, vagy előnyök mellett azért vannak, hát ha nem is hátrány, inkább ilyen limitációknak mondanám. A legfontosabb az, hogy ezek narrowband, tehát keskeny sávú, kis sávszélességű, kicsi adatsebességet tesznek lehetővé. A másik, ami meg kifejezetten az NB-IoT-ra jellemző, a CATEM-re nem, az pedig az, hogy nagy a hálózati késleltetés. Tehát ez azért időnként limitálja, hogy milyen alkalmazási területen használható és milyen nem. Még egy picikét, ennél több technikai részlet nem lesz, és ezekből se fogok elveszni. Picit jobban megnézzük, hogy akkor broadbandhez képest nagyjából hogy néz ki, ezt láttuk, de nézzük meg, hogy egymáshoz képest, tehát a narrowband IoT és a CATEM, plusz most még mellé tette a CAT egyet, ez kicsit ugye a broadband meg a narrowband határmezőjén lévő technológia, szintén ez mind 4G-n belül kell érteni, hogy ezek hogy viszonyulnak egymáshoz képest. Az NB-IoT és a CATEM között, hogyha a legmarkánsabb különbségeket keresem, akkor igazából a fogyasztásban nagyjából egyformák, tehát ott nincs markáns különbség. A sebességben nagyon is van, tehát a CATEM, hát ez az legföl 1 megabit per szekund, ezek elméleti sebességek, mi a éles környezetben azt tapasztaljuk, hogy valós környezetben, hogy azért ilyen 100-200 kilobit per szekre kell gondolni, de ez még mindig sokkal nagyobb, mint a narrowband IoT-nak IoT-nek a pár 10 kilobit per szekundumját. Tehát ezek ma már, ahhoz szoktunk, hogy 4K-t streamelünk valós időben mindent, tehát nyilván ezek nem azok a felhasználási területek, amikre ez való, viszont az IoT alkalmazások nagy részére ezek untig elegek, ezek a sebességek. A másik a különbség az érzékenységben van, ahol a KATEM is nagyon jó, de az MBIoT az még egy lapáttal rátesz erre, illetve a hálózati késleltetés, ahol megint csak a KATEM-nek van előnye. Tehát látjuk, hogy sebességben, késleltetésben a KATEM a jobb, érzékenységben és fogyasztásban pedig talán egy picit az MBIoT. És ez meg is határozza, hogy melyik alkalmazási területre melyiket érdemes választani. Most nyilván ezek ilyen nagy gombócok, tehát azt mondja, egy mezőgazdaság, tehát ez nyilván egy óriási terület IoT szempontból is, ezek csak ilyen durva megközelítések, amikor van egy konkrét feladat, van egy konkrét IoT alkalmazás, akkor nagyon szépen ki lehet választani, hogy melyik az a technológia, amelyik a legjobban passzol rá. Mivel azért ezt már elég régen űzzük, azt hiszem, hogy a legelsők között voltunk még világszinten is, akik belevágtak ezekbe a technológiákba, ezért már egy egészen széles termékportfólió épült köré. Itt vannak olyan termékek ebből, amik úgymond általános célú, tehát tulajdonképpen bármilyen eszközt, aminek valamilyen standard interfésze van, azokat képes rákapcsolni egy IoT megoldásba és egy IoT hálózatra, illetve vannak olyanok, ezek főleg ilyen mérőgétvélyek, szenzorok, amik meg teljesen speciális megoldások, tehát egy konkrét feladatra lettek kifejlesztve. Anélkül most itt belemennék a részletekbe, csak egy-egy dolgot emelnék ki, tehát még a villanymérőknél, ahogy mondtam, hogy ott a KATEM-et javasoljuk elsősorban, mert olyan hálózati protokoll van, ami a késleltetésekre érzékeny, beépített antennával rendelkezik, az alacsony fogyasztásnak köszönhetően, hogyha áramkimaradás van, tehát nem kap áramot maga az IoT gateway-ink sem, attól még működik tovább, és képes erről ugyanúgy információt küldeni központi rendszerből, hogy elment alól az áram. A gáznál ott nem csak, hogy a áramszünet esetére, hanem ott egyáltalán nincs vezetékes tápellátás, tehát a gázmérő gateway-ink az paraméterezéstől függetlenül 11-15 évig képes egy elemről elmenni, mindenféle karbantartás elemcsere nélkül. Nyilván mindenhol, ezekben az eszközökben, mindenhol speciális beépített antennákban kell gondolkodni, tehát itt azért eléggé kifinomultnak kell lenni a rendszernek ahhoz, hogy ténylegesen tudja hozni ezeket a paramétereket. Ez a vízmérő gateway nyilván itt a nagy kihívás, ahol ezeknek a technológiáknak az extra érzékenységét tudjuk használni. Ezek nagyon sokszor föld alatt vannak, vasbeton, falak között, egy vas tetővel lefedve, tehát ezért mondjuk a mobil technológia és az ilyen hullámterjedés szempontjából messze nem ideális szituáció, de ezek a technológiák ezek megvalósíthatók, és erről konkrét tapasztalat van, ezek élesben működnek ezek az eszközök ilyen körülmények között. És persze vannak, amiket említettem, hogy nem speciális cél, hanem igazából bármit rá lehet, van köztük egyszerűbb gateway, van egyszerűbb router, bonyolultabb router. Nyilván most nem az a cél, hogy átmenjek az összes feature-ükön, csak hogy ezeknek is nagyon sokféle lehetőség és nagyon sokféle interfésszel rendelkezésre, hogy különböző eszközöket ezekből az IoT alkalmazásokból be tudjunk húzni. És végül talán ezeket van kezdeni, mert ez volt az első narrowband IoT-s megoldásunk, ez a parkolószenzor, ahol a mágneses és radaros megoldás kombinációjával állapítjuk meg, hogyha elfoglaltak, vagy ha felszabadult egy hely, és itt is kihasználva az alacsony fogyasztást, meg a jó terjedést, itt is 5 év fölötti átlag élettartamot tudunk biztosítani egy darab beépített elemmel, mindenféle karbantartás nélkül. Az eszközökről talán ennyit, még egy gondolat, mielőtt befejezném, hogy amit már az elején is utaltam rá, hogy itt az IoT-nál az eszközök dolog, nagyon fontos, de az, hogy központilag ezek menedzselhetők legyenek, az legalább ugyanolyan fontos. Tehát itt tényleg abban kell gondolkodni, hogy ezek az eszközökhöz fizikailag nem lehet kimenni. Tehát van egy élettartamuk, és az óriási plusz költség, és nyilván nincs az annyi erőforrás, amivel ki lehetne menni mondjuk több százezer ilyen eszközhöz mindenfelé a világon vannak, ezek között nagyon sok olyan, ami nagyon megközelíthetetlen helyen van. Tehát itt létszükséglet, hogy maga az eszköz önmagával teljesen robosztus legyen, tehát nem folyamatosan üzembiztosnak kell maradnia, és nagyon fontos, hogy távolról mindent el lehessen rajta végezni. Az adatait összegyűjteni, átparaméterezni, fölvet frissíteni, folyamatosan monitorozni, elemállapotot, térerőt, minden egyéb körülmény. Tehát igazából így ezekből az elemekből állíthatók össze ezek az IoT alkalmazások. Körülbelül ennyit szerettem volna elmondani. Remélhetőleg sikerült a rendelkezésre álló időkeretben azért egy picit az alaptechnológiától megvilágítanom azt, hogy állnak ebből össze a konkrét megoldások, és tényleg azt szeretném kihangsúlyozni, hogy ezek nagyon fontos rendszerek, és egyre több ilyen fog megjelenni az életünkben, mert ezek nem a nice to have kategóriát képezik, hanem ezek feltétlenül szükségesek arra, hogy azért egy fenntartható környezetben korábban megszokott életminőséggel élhessük tovább az életünket. Ezzel megköszönöm a figyelmet.
It was a great presentation. Thank you very much. And as we are going further and further in Europe, really international, I'm greeting our friends in Netherlands. Hi, Owen. Hi, Daniel. Let me introduce, hi guys. Let me introduce these two gentlemen who are working for E.ON Technology Company. Owen is a marketing and BDM manager for Europe, and Daniel is a software architect at E.ON Europe. The topic is very, very interesting, and not easy one. It sounds how to expedite robotic development. The robotic development, artificial intelligence, and anything around robotic is gaining on importance these days. And our two presenters today will show you how you can expedite your robotic development in general. Before we start and dive into the presentation, let me ask you a question. This one is for Owen specifically. So we are normally working with ecosystem partners to build artificial intelligence and IoT hardware. Can you describe what can we imagine? What does it take and what is behind all this? Thank you.
Yeah, sure. Thanks for the introduction. And today we are happy to join the DEBATECH conference. So let me take the first question. So E.ON, as far as you know, I think it's the hardware manufacturer. While we discover more and more customers are looking for solution that is validated and integrated with the essential software components or even the hardware components to build the whole solution. So that it could help them to shorten the development cycle and reduce time to market. Then that's why E.ON start to find different partners within AI and IoT ecosystem. The first step, we work with NVIDIA and Intel to enable essential toolkits or frameworks for different applications development. For example, like Intel OpenVINO for AI, Intel RealSense SDK for 3D vision or mapping in AMR application as an inference, or NVIDIA ISAC SDK, which we will talk later in our slides for AI or robotic related applications. Then with the foundation we built from that step, we then find different independent software partners or vendors to build their applications on top of our platform and bring this to customer that is looking for applications level offerings, such as quality inspection, smart surveillance, or MR, etc.
Thank you. Handing over to you guys.
Okay, so I'm Owen Wei, and together with my colleague Daniela, we are happy to join DEBATECH conference together today. Then we are going to share our expertise and Aeon's autonomous mobile robot solutions. So first, let me cut in from a market perspective to give you a background of how AMR market will be in the future. So AMR market size stood at 1.67 billion in 2020, and it is expected to reach 8.7 billion in 2028, with an annual growth rate of 23.7%. So why AMR grows so rapidly? What factor plays important role here? The growth of e-commerce has always been a key factor that boosts the growth of AMR due to high labor demand in distribution center to address the booming number of the orders. And the COVID-19 also gives a hand on e-commerce as people couldn't go out for travel, so that they have more time and money to browse and purchase items through internet. And the pandemic also makes situation of lacking workforce even severe. Therefore, implementing AMR seems to be the optimal option for company to stay productivity, not only for current situation, but also for the future. So now we know what's behind to push AMR. Now I'm gonna talk about the benefits it could bring. I just named a few here. So for example, not many people would like to take night shift, so that employer would need to pay more to ensure continuous operation. But with the help of AMR, employer could then reduce labor cost and avoid workforce shortage. Besides, AMR is operating through accurate algorithms, so that it can keep consistency and avoid mistakes even after long working hours. Thus, combined with a non-stop operation, it can increase productivity. Besides, the AMR is linked to the warehouse management system, so that every step is recorded for traceability. And the AMR could move around the production line or warehouse, so that it gives high flexibility in the layout of either warehouse or factory. I will talk more about this in later slides. So as you can see here, there are many benefits of AMR. So in these slides, I would like to showcase some possible applications which can be achieved by AMR. You can see there are different AMR for variable applications in factory or warehouse scenario. In the command center or on production line, few employees are working with a human-machine interface. Normally, it's like a tablet or the touch panel to ensure everything works well and check on real-time operating data. Then in the production or packing or delivery area, there are AMRs designed for different specific purpose. For example, there are equipment maintenance robots for regular maintenance tasks. And there is sorting robot to sort the right package, or material handling robot to execute goods to person task, so that it could reduce the time employees spend to get the exact item and increase efficiency. Or there is a robot that could help to automate the inventory management process. Through the evaluation of AMR robotic technology, there will be more and more interesting applications in the market that users could leverage to enhance the efficiency and automate their process in the production site. And in these slides, I would like to talk more about how AMR could evolve the assembly line. When AMR is each station within the production line, it could give the flexibility and the scalability. For example, after a certain station within the production line, you would probably need to do like an additional QC test, while you don't want to move all the equipment here. Then the flexibility of AMR could allow you to just move this section to the QC department without too much hassle. Or you would like to add additional stations for different tasks, you could also achieve through the scalability of AMR. Thus, the AMR gives the interoperability with other department, like you could directly move the finished goods to warehouse right after the process, then arrange for packing and delivery. So you have heard about the good points of AMR, but we all know it ain't easy to develop one by ourselves. A solid robot will require many components to work seamlessly to function properly. In such case, select right hardware components and the integration with the software stack have been extremely important. So how Aeon helps to solve these pain points? Let's take a look from the bottom to top. First, Aeon is hardware manufacturer, like I mentioned at the beginning, to provide options for different computing platforms. The most popular two are Intel and NVIDIA. Then, like I mentioned, only one part, only hardware parts like computing unit is not enough. We would also need like a robotic SDK and essential components to have a seamless integration, then to make everything work without issue. So we have engaged with Intel, NVIDIA, and partner within the robotic ecosystem to enable these SDKs. Regarding to Intel, we have OpenVINO for AI inferencing, one API for heterogeneous computing, and the RealSense SDK for 3D vision or SLAM. Besides, the core of robot, ROS and the ROS2 are also integrated. And as for NVIDIA, we have also the ISAC SDK that is validated together with our platform. Then we work with the partners to sort out the suitable components and integrate the essential software components to build up the robotic kits based on the either NVIDIA or Intel platforms, which includes the necessary parts to speed up the development cycle for robotic application up to the use case level or application level. So I believe till now I have given you the general picture about the AMR solutions Aeon has and the market perspective and the benefits of it. So now I'm gonna pass the ball to my colleague Daniela to take you dive into the software part, which bring every piece together in the AMR solutions. Okay, so that's my part. So I will hand to Daniela for a more detailed introduction regarding to software part. Thank you.
Thanks, Owen, for your introduction. I'm Daniele Cleary, software architect at Aeon Europe, and I'm going to showcase first how the Nimbus Cloud software platform works together with our robotic development kit powered by NVIDIA. One of the robotics development kits we have is based on NVIDIA, and Nimbus is a powerful tool that provides you a convenient web user interface to configure, simulate, manage, and control your robots, specifically your robotic development kit from Aeon. In this video, I want to show you how it's possible to add a LiDAR sensor to your robot. So you see here from the web UI, you can select a new sensor and adding the sensors specifically to the robot. You can position it in the right height and within the robot itself so that it can be used by the software. Here we can adjust it manually using the convenient web user interface. And once done, you can see the robot leveraging the LiDAR, the new LiDAR sensor added in the simulation environment. In the other slide here, we are going to showcase the online visualization tools. Here you can see how you can remotely control and manage your robots with Nimbus. where you can assign a new mission, in this case, navigating from A to B, with obstacle avoidance. The robot includes both a LiDAR and a real sensor. Thanks to the Nimbus integration with NVIDIA and Isaac SDK, the ROS2 deep learning components can leverage the GPU acceleration on our device for AI inference application and also for other tasks performed by robots. As mentioned earlier, with Nimbus, we have a convenient web user interface to configure the various aspects of your robot. And for example, here we can add a new algorithm to our robot, in particular the exploration algorithm. And we can link first the camera sensor to the robot, and then add here the new exploration algorithm to the rest of the robot's software stack. And then once the component is available in the web user UI, connect the variables, the input variables and the output variables to the rest of the robot software, so that we can, once completed, deploy the solution directly to the robot. Our robotic development kit powered by NVIDIA supports the NVIDIA Isaac SDK. Thanks to the integration with Nimbus, it is possible to use the Isaac engine to leverage the NVIDIA GPU for acceleration of AI tasks and all the other tasks developed and used within the robot. Many Isaac gems are already available and integrated with the Nimbus interface. As you can see here, there is a list of some of the gems available from Isaac SDK. And then, if not added already, they can be easily included with minimal integration effort. To showcase an example of an NVIDIA Isaac gem, here we're going to show you how the Isaac follower gem is running on our robot. The robot, while tracking a person, can detect also the poses and action that the person is doing and follow that person, as you can see from this video. You can see the action performed by the person under the left video. And the robot following the person while the person is moving. Another example we want to show here of integration with the Isaac SDK is the use of site and website visualization tools. In particular, website here is shown as integrated within Nimbus. Website offers API that can be used to create variable plots or to visualize data in 2D and 3D renderings. In this case, you see the 3D of the 3D visualization of the room with the visual odometry of our robot. In our robotic solution, we also have a platform based on our Up series product powered by Intel technology and the Intel Edge Insight for AMR software development kit. In this simple diagram, we can see the hardware setup of our Up robotic development kit. On the left side, the motor control board is based on STM32 microcontroller, is connected to 4 EWM motors, an IMU sensor and battery, and it communicates via UART over USB with our main compute unit that is powering the robot. The kit we provide comes in two flavors. One is based on the UpSquare 6000 single board computer powered by Intel Atom 6th generation system on chip. And on the higher performance, we have also the solution based on UpExtreme i11 powered by Intel Core i11 Gen system on chip. And the app robotic development kits come preloaded with Ubuntu Linux operating system, specifically 2004, and the Intel Edge Insight for autonomous mobile robots software development kit. The SDK offers containerized software packages for sensor data ingestion, classification, environment modeling, action planning, and action control. Looking at the software stack, we can see that the SDK is based on the robot operating system 2, ROS2. It also includes OpenVINO toolkit, Intel API 1 base toolkit, Intel RealSense SDK, and other software dependencies, all running from a container, alongside with the source code and reference algorithms and deep learning models as working examples. In addition to autonomous mobility, this package showcases map building and simultaneously location and mapping loop closure functionality. AI workloads are run on the integrated GPU of the robot main compute unit or on Intel Movidius MiraDex accelerator. As you can see, the platform is based on standard Linux operating system with standard Linux driver. The main applications available where to start with the robotic development that are included in the SDK are the fast mapping, which helps to generate 3D map of the environment from the included RealSense 3D camera, including providing the position of the robot. The main application is the Wandering AI application, which combines the middleware software and algorithms to move the robots around the room with obstacle avoidance and local mapping generation in real time, all together with AI object detection. At last, we also have a Gazebo robot simulator application to rapidly test algorithms, design robots, perform regression testing, and train AI system using realistic scenarios. Included in the SDK documentation, there are also other tutorials from basic ROS2 tutorials, GStreamer pipelines, OpenVINO sample applications, One API sample applications, and so on. Here you can see an example of the Earthbeats visualization tool with our robot, and on the right, the ROS2 nodes and their interaction with the to control the robot. You see the way they communicate with each other and how the robot is able to move thanks to ROS2 and the integration performed within our robot. All the information can be found on the documentation of the Wandering application with our robotic development kit directly on the Intel website. And this is all about our robotic development kits. Thanks.
Thank you very much. Our next presenters are from Sensirion Company, Marco Gisel and Antonio Rubino. Their topic is about the air. Get the full air quality picture with a single sensor solution. Both of them are product manager at the company. These talks will illustrate the impact of the most relevant air quality parameters and how it can be measured. Marco, let me ask you a question. How good are humans at perceiving the air quality at their surroundings?
Great question. So first, thank you so much for having us today. We are very excited about today's webinar. How well are humans at perceiving indoor air quality? Well, it depends. There are some aspects of indoor air quality that we perceive very well. One example would be relative humidity. You get dry skin if it's very dry, and you would also feel if it's very humid. But then there are other aspects to indoor air quality that we perceive decent, like volatile organic compounds. Some smells we perceive very well, others not so much. And then there are aspects to indoor air quality that we don't perceive at all. And I think a very good example here would be carbon dioxide or CO2. With that, welcome to today's webinar. Who are we? My name is Marco Giesel. I'm a business development manager with a passion for clean indoor air. And today here with me is Antonio Rubio, who is a product manager for our sensor environmental node. What will we cover today? First, we'll talk about why we should care about indoor air quality, and then second, what the pollutants are that we encounter on a daily basis. Part number 3, I will hand over to Antonio for that, will be about our environmental node, the SCN5X. Part number 4, we will get very specific on how you can get started with our air quality sensors. Before we start with the actual presentation, few words about our company. Sensirion is headquartered in Switzerland and was founded roughly 25 years ago. Since then, we grew a lot. We are now more than 1,000 full-time employees. We have a global presence with sales subsidiaries, but also operation sites in Europe, Asia, and the US. We sell to many different markets. Some examples are being displayed here. Medical, automotive, but then also consumer-grade products are among our customers. We are one of the global leaders of air quality sensors. We sell them to air treatment devices, such as air purifiers, but also to indoor air quality monitors and to HVAC system. So HVAC stands for heating, ventilation and air conditioning. I already mentioned that we are a leading manufacturer of air quality sensors, or environmental sensors, how we call them, but we are also a leading player in the field of flow sensors. We sense liquid flow, but also gas flow, and then also differential pressure. With that, let me get started. Why should we care about indoor air quality in the first place? And I think a very prominent example that most people associate with indoor air quality these days is COVID. A few months ago, a professor from the Imperial College London said that we do not build up herd immunity through Omicron to the extent that we were hoping. We don't produce as much antibodies as we hoped. Now, what does that have to do with clean indoor air? It turns out that almost all COVID infections happen indoor, and most of them are transmitted via so-called airborne particles. So these are aerosols, just very small water droplets that contain the COVID virus. Turns out that masks do help against this form of COVID transmission, but it's not a full solution. We see more and more viral mutations, so the vaccine is also only partially helpful, and there's a huge suffering from long COVID around the globe. One of the most effective ways to tackle COVID is to control our indoor air quality and thereby ensuring that airborne transmission is reduced. And because of COVID, the mass media is full of articles, or television shows are full of reports on the importance of clean indoor air. Most of them associated with COVID infection risk, but indoor air quality is much more than that. It's important to realize that there are also other chronic diseases associated with bad indoor air quality and many deaths that can be accounted for bad indoor air quality. Governments around the globe noticed that this is a very important topic. They gave out recommendations, but not just that. They also invest heavily into clean indoor air quality. We see that in the US, We see it in Europe, but also in Asia. Typically, they encourage public places to display air quality in some form or another, to renew ventilation systems, or to add air purification systems to public places. The maybe most prominent example of that is the Clean Air in Buildings Challenge from the US. So the White House earlier this year declared that some of the ARPA, that is the American Rescue Plan funding, can be used to mitigate or to improve indoor air quality. And these funds account for roughly $470 billion US. So that's a gigantic sum. And what this Clean Air in Buildings Challenge does, it's a call to action for building owners and operators with 4 very easy steps. Step number 1, create an action plan. So understand your air quality or the status quo. Step number 2, increase or optimize air ventilation. Step number 3, add air filtration. And then 4, engage your community. Let's take a closer look at step number 2 and step number 3. Optimize air ventilation. Why would you want to do that? Turns out that there are aerosols very stable in the air containing COVID viruses. We can dilute them by bringing in fresh outer air and replacing stale indoor air. There are scientific studies that show that up to 80% of COVID infections can be prevented simply by having high ventilation rates. Air filtration, very similar picture. We can filter out aerosols that are stable in the air. Also, there scientific studies show that up to 80% of COVID cases or COVID infections can be prevented by having proper air filtration, specifically MERV 13 or higher. These are great news. All we need to do is run the ventilation at full speed all the time and add air purification. Unfortunately, it's not that easy. Clean indoor air comes at a cost, and these costs are CO2 emissions. Turns out that HVAC, heating, ventilation, air conditioning systems account for more than 6% of CO2 emissions globally. To put that into perspective, aviation, that would be passenger and freight, accounts for only 2% of global CO2 emissions. So, heating, ventilation, AC, 3 times worse. We need to balance these 2 things. On the one hand, we need to have healthy indoor air that makes sure that people don't get infected with COVID. On the other hand, we need to be energy efficient. To have both, we need smart ventilation systems that make good informed decisions, and to do so, our air quality sensors are necessary. CO2 sensors help our HVAC customers to use so-called demand-controlled ventilation, and then our particulate matter VOC sensors help the optimization of air purifying devices. I hope I was able to convince you that air quality is a very relevant topic, and with that I would like to talk about pollutants that we typically encounter indoors. These are the 5 ones. I will talk about them in a minute, that we typically see indoors with a source that is actually indoors. But then it's also important to understand that indoor air quality often depends on outdoor air quality, because whenever you open a window, you let outdoor air pollutants come in, such as PM 2.5 and NOx. The pollutant that maybe got most attention throughout the COVID crisis is carbon dioxide. Why is that? We exhale CO2. In confined indoor air spaces, CO2 can accumulate over time, and high CO2 concentration has an impact on our cognitive performance and on our well-being. But it's not just that. It's also a good proxy for aerosols that we exhale, so tiny water droplets. That could potentially include COVID viruses. So by measuring CO2, you can somehow get a proxy for COVID infection risks. How is it measured? With so-called optical non-dispersive infrared sensors. CO2 is chemically inert. We need an optical source to measure it. And there are two different types of NDIR sensor. The one is transmissive or optical detection. The other one is acoustic detection. Sensirion has both of these technologies in our lineup. Our newest generation, the SCD4X, is acoustic type. It's the smallest optical CO2 sensor on the globe at the time of recording. It is truly selective to CO2 and it's reflow solderable, so thus making it easier to integrate and manufacture. Going on to the next pollutant, one that is maybe most prominent, that is PM2.5, particulate matter, or also smog. These are very tiny particles. To get a sense of how small they are much smaller than human hairs and fine sand beach that we know. The smaller the particles, the more dangerous, because they can penetrate deeper into our lungs and into our blood system. And they are responsible for many deaths globally. How do you measure that? You measure that via so-called laser light scattering. The way it works, you have a laser that shines on an airflow, and whenever there's a tiny particle, light is scattered, that is detected by a dedicated detector. Our solution to that, the SPS 30, offers long-term stability. That would be 10 years plus. It comes with an algorithm that allows to differentiate between particle sizes, and it is also very performant across different aerosols. Pollutant number 3, that is somehow more complicated, are so-called volatile organic compounds. So that is a class of molecules that is in the gas phase at room temperature. And sources are very different. If you use a deodorant or a perfume that smells nice, that's a VOC. If you drink wine, ethanol evaporates, that's a VOC. But then there are also very harmful VOCs. And these are very different to distinguish. That's why they are oftentimes measured as one entity called total VOC, total volatile organic compound. NOx, so nitrogen oxides. Typically, this class of pollutant originates from a fire or a burning process. So indoor sources could be cigarette smoking or a gas cooking stove, but then outdoor sources would be traffic. The way we measure, or also the industry standard to measure these two types of pollutants, are with so-called metal oxide sensors. The way they work is to have a sensitive metal oxide layer that is heated up to a very high temperature, several hundred degrees Celsius. When a molecule hits the selective layer, it gets either oxidized or reduced, and that changes the resistivity of the material. Our solution, the SGP4X, offers two independent outputs, VOC on the one hand, NOx on the other hand. It comes with superior reliability through lifetimes and with algorithms that make sure that the user experience is great. Moving on to the maybe best known air quality parameter, that would be relative humidity and temperature. And that's a classical example of something that we perceive very well. So these two things on the one hand have an impact on our immediate well-being and cognitive performance, but on the other hand, they can also be correlated with chronic problems. As an example, if the relative humidity is too high, mold will grow, and that can lead to chronic respiratory illnesses, diseases. The way to measure that is with a capacitive sensor. So you would have, let's say, selective or a material that where basically water molecules can diffuse inside and thereby change the capacitance of this layer. Sensirion has been the market and technology leader for this type of sensor for 20 years plus. We offer the lowest power consumption and many specialized different product variants. Going on to the last slide, from my side, formaldehyde has been a huge topic in Asia, specifically China. Technically speaking, it's just one of many VOCs, but there's a high attention on formaldehyde for two reasons. One, it is very dangerous, it's associated with cancer, and two, it occurs quite frequently, also at high concentration in indoor air spaces. Typical sources are new furnitures, especially the wooden furnitures. The way to measure formaldehyde selectively is with electrochemical sensors. Basically, they react, or there's a cathode that reacts with the formaldehyde and thereby produces a current that is proportional to the formaldehyde concentration. Our formaldehyde sensor, the SF-A30, offers the lowest cross-sensitivity to VOCs. It comes with an advanced relative humidity compensation, and it also has a very long lifetime of up to 6 years. With that, I conclude the second part and hand over to my colleague Antonio.
Thanks, Marco. So let's move more into the application and our solution with our sensor node. So let's take as an example an application requiring the measurement of PM, VOC, NOx, humidity and temperature. As explained by Marco, these are relevant parameters to monitor air quality. In this case, we need up to 5 sensors, and in order to implement the applications, we need to connect them with cables, electronic boards, and so on. So looking at the final application, it looks like how it's showing in the slides. So it requires a big dead volume, and the final result will be a complex interface. The implementation requires high integration effort. Several iterations will be required to get the final product, and also if the process is successful, the final application will require considerable space, and the supply chain will be really complex, and everything results in long go-to-market time. Sensirion is happy to introduce our solution to this problem with SEN5X. It's a combo module, really compact and easy to design in. So your application results in a robust supply chain, and everything is optimized to get the best for each single sensor. So you can measure each single parameters in the best way. So SEN5X will have a 5 voltage supply voltage, and includes an R2C interface and an operating temperature from -10 to 50 degrees Celsius, and a lifetime of more than 10 years thanks to the sheet flow technology. For PM, we have the patent airflow design, and there are different beams, and the sensor can measure PM1, PM2.5, PM4, and PM10 with best precision at PM2.5. For temperature, the module includes temperature acceleration and compensation engines, and with an accuracy for humidity of 4.5% and a temperature accuracy of 0.45 degrees Celsius. For the VOC and NOx, we all know it's really difficult to deal with the output of the MOX sensors. That's why Sensirion has implemented an index concept. For both VOC and NOx, there is an index with a range from 0 to 500. And the sensor, together with the algorithm, identifies an average, a background, giving a value of 100 for VOC and 1 for NOx. This is because we always have a background for VOC, while for NOx in normal condition, we don't have presence of NOx. The idea of the index is to identify trends. So if there is a variation, the index increases. If there is a variation towards better air quality, the index will show lower value. And ideally, this is really easy to implement and can be used as a part of a closed system. For example, for an air purifier, this can be used to understand when and for how long and for with which power the purification needs to be activated. Regarding humidity and temperature, Sensirion features the STAR engine, Sensirion temperature acceleration routine engine, to accelerate the reading of temperature. And thanks to the algorithm, the time the end user will have the value can be reduced by 2-3 times. This acceleration is tunable with 3 presets: low, medium, and high accurate acceleration. And also accuracy is reached by compensation, so value of plus minus 4.5% in humidity and 0.45 degrees in temperature accuracy can be reached also with the end product. So let's move now to the start, to how to get started. Everything starts with the evaluation. So customer can start the journey ordering our evaluation kit, the SEC SEN5X. That includes everything you need to start the evaluation. So the module and cables to connect directly with the PC. The module is more than 5 sensors put together, since there is a single interface and all the algorithms are already implemented and the sensors are calibrated. So there is an advantage also from the hardware side, because all the sensors sit in the right position with the optimized flow and all the compensation to work in the perfect way together. Typical examples where to find application of SEN5X are indoor quality monitors. Due to the compactness, the end product can be really small, compact, and smart, measuring all the relevant parameters. And as I mentioned also before, typical applications are air purifiers, where sensors are used to quantify and trigger the actions of the purification. So to summarize, Marco talked about what's important, how measure air quality, what are the relevant parameters, and we also show nice solutions to measure all of them together in a combo with relevant application for air quality monitors and air purifiers. Thanks for your attention. Here are a list of links and documents for your reference.
Let me present you the next speaker, who is Bystrik Micek from Workmotion company.
Thank you, Thomas, and welcome everybody in our SOS Electronic headquarters in Slovakia. Oh wow, very interesting and useful presentation today. I hope that all of you are enjoy DEBATECH event as me. As you know, and we know it, the product development is not only about electronic components and technical stuff, but also about product design. Everything what is made in your manufacturing is made probably for a customer, for their home, for their job, for their business. That's why it's very necessary to have not only perfect technical performance, but also good looking and design thinking product. Let me introduce you our next guest or speaker if you want, Mr. Bystrik Micek from amazing Slovak design studio Workmotion with a very interesting topic.
The development of industrial design and its impact on the product and the brand. Mr. Micek is a CEO and remained also a design manager in the company. The company has international clientele, and the greatest projects which are the most proud of are, for example, Nexineo virtual computer equipment, the Behard new fleet on the ship in the Hungary, Albertina river cruiser, which is located on Danube and transport from the Germany to Ukraine. Before we start, let me ask you the general question. How important is a design in the whole process of products development or production?
Industrial design, product design is very important for the manufacturing of the products, but in general, the main value is to create the brand itself.
Thank you for your answer and enjoy the presentation.
Hello everybody, it's my pleasure to present you our design studio and our work, what we did in last several years. The presentation will consist from three parts. First part will be brief introduction of the company, second part will be overview of our references from different industries, and third part will be very simplified use case scenario of our one selected project to give you a little bit more imagination about the product design development itself. Verkimotion is research and development industrial design studio located in Bratislava, Slovakia, Prague, Czech Republic, and Taipei City in Taiwan. We are a young team of very experienced designers from different fields. We are focusing on three groups of industries mostly. It is like automotive industry, like automotive and utility vehicles design, after naval design, consumer and electronics and medical design. We are also have protected many designs by IP rights protection, over 12 design registrations and patents all over the world. We were also awarded by top design awards like Red Dot Design Award, EF Design Award, the German Innovation Award, and as you can see also on the picture, we have very strong business partners, and our designers has also really strong previous design experiences from automotive industry. Let me show you our main overview of our references. They will consist from three main industries. We will start with automotive and agrotechnic industry, after naval and shipbuilding industry, and we will finish with consumer electronics and medical devices, what we were working on. Our first dominant reference from automotive industry is brand Torsus, where we were designing several types of vehicles, mostly focused on the off-road buses. In front of you, you can see Torsus Praetorian, which is 14 tons big off-road bus focused to use only on locations where is no infrastructures. We designed all visual parts of the bus and also supplied all manufacturing data for the visual parts like a fiberglass, glass, bended glass, etc. We also implemented many OEM components into the product, and we also closely worked with the client's engineering team, which was really nice, a synchronized cooperation. In front of you at the moment you can see the several configurations what we did also from this bus. The bus is at the moment set to be able to use for many different applications as a tourist bus or firefighter version or only regular coach. Second vehicle from the Torsus portfolio is Torsus Terrastorm, which is the smaller version of the off-road bus. It is the conversion of Volkswagen Crafter. The product is a good example how a design language can be replaced from one vehicle to another one by implementing the main key features on the front bumper and redesigning several parts of the product, also with adding livery design on top of that. We are also present in motorsport industry. One of the projects that are very strong from this segment is Dakar truck Fesh from the Czech Republic. We were designing the whole exterior design and manufacturing data for this vehicle in close cooperation with the client's engineering team. We were also designing livery designs and many technical details about implementation of OEM components. Another strong reference is also one of the biggest producers of the tractors from Slovenia, Agromechanika, where we were also designing the whole range of the tractors with and without a cabin. We were supplying the full development of the design styling, design language for the new brand, and also providing manufacturing data. All visible surfaces were developed in a close collaboration with the client's engineers and suppliers. The next industry is naval and shipbuilding. In this industry, we have several references with the built results. The ship in front of you, it's called Albertina River Cruiser. It's 110-meter hotel ship. It was developed in a shipyard in Komárno in Slovakia. In this type of projects, we're cooperating with a specialist from naval architecture, naval engineering, one of the biggest office in Europe, which is present in Netherlands, Belgium, and also in Slovakia. In case of these references, we also developed and designed another ship, which is Danube ferry, for the transporting of the passenger cars or even the regular pedestrians from one side of the river to another one. The project was built also in Slovakia. At the moment, we are also developing in cooperation with the naval engineers the new fleet of Bahart ships for the Hungarian Lake Balaton. The new fleet will consist from the 4 ships, ferries and catamarans, what you see in front of you. We were completely supplying full package of design services for exterior design, interior design, livery design, selection of OEM components and many other parts. We were also in close cooperation with the production suppliers for the fiberglass, plastics and also for any other glass and metal parts of the boat. The second ship in the fleet is Bahart ferry, which also using the same design language what was developed for this whole new brand. As you can see, the livery design is one of the key elements, also with the main contour design and shut lines, which defining the really strong identity for the product and the whole brand. We were also developing floating piers. For example, this one was built in a shipyard of Bratislava and it's used on the Danube River. The project came in very raw state to us. As you can see on the right picture, it was only a few containers on the top of the box, and we completely moved the development of the floating pier to another level and defining the new element of the design shaping using different combination of materials and also with a very keen focus on cost-effective development and production. In case of consumer electronics and medical design, one of our strong business partners are one of the biggest producers and developers of dentist chairs and dentist units in general, company Diplomat Dental Solutions. We started cooperation in 2018. From that time until today, we developed the whole product portfolio together with their engineering team and our design team together. The whole portfolio consists from many technical details, which were completely going from the small parts to the whole units. We were designing and developing all visible surfaces. We were also communicating and being in contact during development with many production suppliers for plastics, upholstery, ceramics, metal shaping, bending, and metal casting. This type of the products also involving many OEM components and electronics, many kinematics, and many other limitations which are very restricting in the case to find really nice and beautiful design language and identity. But as you can see, we were very successful. Project won all top design awards in the world, and it's helping to grow the sales of the company. The product by itself, it's very minimalistic, and that therefore we predict that will have long lifetime. Another references from consumer electronics and product designs are PC terminals, where we use combination of metal sheet bending and fiberglass, small computers, and even innovative office chairs. Another very interesting project from the electronic department was also multiplayer gaming drones. The really interesting and really big challenge here was also the size of the product, which is about 10 centimeters. And the all details and assembly was very complex, also with the hardware and other OEM components involved. In this project, we were also developing the whole packaging of the product, boxing by itself, and all graphics, what is used on. One of the latest and really strong and nice project from the consumer electronics are performing lasers for company brand Quant. What you see in front of you is the comparison also from the previous and current version. The old Quant design on the right side, the boxy design, it's a very common solution from the whole laser market. And we were able to completely redesign and create completely new recognizable design language and styling of the product, what you see on the left as end result. But one of the very interesting input to that was also cooperation with Slovak Academy of Science and using their developed foamed aluminum, which is expanded aluminum metal, what you can see on the right down corner. The material is very functional in the way of weight reduction and definitely allow us to make much more complex design shaping, what resulted in very fascinating new benchmark on the market with the lasers. In that project, we were also cooperating with the client's engineering team, but all visible parts, all assembly design, and other components which are mounted on everything were coming mostly from our side. What was happening inside of the body with the hardware and the technological part of the product was on the side of the client. Let me show you the third part of the presentation, which is a use case of design product development. We selected very complex product, but in its simplicity is one of the best for this explanation. We selected for this purpose the project Nexino Cloud Client. Nexino is a replacement of the regular PC computer under the table. It's the network of virtualized computers connected to database, which making the main calculations. Nexino by itself is the very revolutionary product because it's reducing the waste, electronic waste, the energy consumption, and also the costs, investment costs to buy the whole set. For this project, we were developing completely full delivery package, which was design styling and industrial design with the engineering. We delivered also livery design, branding, marketing content, and very strong IP rights protection with a really nice network of production suppliers for each part. Nexino, as you can see on the picture, can be mounted on the screen or on the table. For that purpose, there is several design improvements. To simplify design development process, we created a very simple visualized overview how the process of design looks like. It consists from the two phases. First phase is a concept design, second phase is a prototyping and production design. In the first phase, we are focusing mostly on research and analysis of the client's inputs and requests and needs of the users. We also have some inputs in case of the, for example, single board computer in this case. Later on, we create the whole design strategy based on what we create the sketch development step. The sketch development is very important step in the whole process because we create many different identities and approaches on the new design language strategy. From that point of view, we closing the concept design by modeling selected versions of new design approach, and client have the right to choose which direction like to go. We also giving many recommendations due to our previous experiences and the importance fact that the product should have a long lifetime on the market, so it's important that it will stay fresh for a longer time. When the design is selected and we already have clear what is the advantages of the new identity, we starting to focus on manufacturing data, the assembly, the involving all important OEM components, and other parameters related to it. What is very important in that process is to select the materials, the production technologies and suppliers, to know their limitations from the production state point of view, and to define the restrictions of the cost efficiency of the development. Next, in our product by itself consists from several parts. We calling two main parts, which is like body and the mounting element, which is on the screen. As you can see, the body consists from two parts. One is plastic part, which holding the single board computer, and another part is aluminum front cover, which also has function of passive cooling. And we have several other components as front decor, which hiding the screws. The same purpose also has the rear rubber segment, which also has anti-slippery function for the position on the table. And we were developing also extension and base for the button on the top of the device. Plastics used on that project are injection mold plastics, and front cover is aluminum casting to use its ability to distribute good the temperature on the surface of the product. We were also going to the last details and developing the whole livery design, surface finishing, labeling, and application of the labeling and branding on the product. That by itself was a very complex task. To go piece by piece to show you like the complexity of the development, in the picture in front of you, you can see the very pre-selected selection of the development stages, alternatives and prototypes, what we were doing during the process, and the final result on the top. In case of the front cover, as you can see on the picture, we were going from the many different shape alternatives of the selected design, from the negative shape to positive shapes, and later on we were also focusing on surface finishes, on surface finishing, which is much more satin and more premium look without any extra cost. We were also tested many different branding way of application on the front cover, which definitely was the challenge, because as you can see on the picture on the top, not everything was holding tight, but at the end we found the technology which allow us to place on the surface of the front cover branding by the way how we imagined. On the pictures on the bottom, you very clearly see we were designing the cooling chimney, which is touching the PCU of the single board computer and transferring the heat on the outer surface. That was very well tested even before investment into the molds, which are pretty expensive. So we're trying to avoid any mistakes during that process. Therefore, we ordered 3D printing of aluminum part, which was tested for heat distribution even before the molds were start to be designed. On the left side of the picture, you can see three different angles of the 3D printed aluminum front cover, what was used for the testing of heat distribution and assembling with the plastic part from the behind. On the right side of the screen, you can see the already final casted aluminum parts, which were already mass manufactured. As you can see on the two samples on the left side, one is with and one without the surface finishing, which later on helps us to get this premium look of the more satin surface finishing. All these parts, not only this front cover, is designed for as simple and cost-effective production of the molds, which later on are saving a lot of investment costs in the tooling. Here is another comparison where it's very important to design also livery design during the process, also with the cooperation with the production suppliers, because it has really high importance on the final look and feel of the product. On the right side, you see the same piece with only defined better surface finishing, which is simulated also on the plastic parts and synchronized together. Very important part is also the assembly design of the parts. Specifically in this project, it was very challenging because we needed to connect aluminum casted part with a injection molded plastic part, which has a different contraction of the size and also very different surface finish strategies. On the left side, you can see also the brief development of the inner side of the body, where is placed a single board computer, and also same time you can see development of the rail for mounting on the back of the screen. Next part, and very important part, was also the mounting element, which is on the screen, which involves a sliding rail, because the important input from the customer was that the device shouldn't be screwed on the monitor, it should be able easy to be placed down. As you can see on the pictures, there we had several design versions of that mounting element. Our goal was to achieve as most simple version, not only from the cost-effective way of producement, but also to not spend many material per piece. And also is achieved same principle to limit the production mold to be as simple as possible, from less pieces as possible. Very important part of the whole development is also many revisions and iterations during the process. Of course, because our previous many experiences from different fields, we are very able to decrease the number of the iterations during the process. We are also very focused on the details on the projects. One of the really small detail of this Nexino product was also the whole button units, which consists from the base and the top extension of the button. We developed different concepts how it could work, but also the main target was the simplicity of the solution, which can be really durable for the long period of time, and also the production costs and complexity for the molding. We added also several additional services which are very complex and typical, and we are very happy if we are able to do that. Mostly it is like IP rights protection of the final design, branding from the product, which is the real part of the product itself. And in this project we were also able to create several animations and drafts for a website and other marketing content. For final imagination, how big impact we can create with a product design or industrial design is this slide where we comparing the competitors on the market with the client's previous product and final solution. As you can see, all products or the most of the products are circle or boxy style. As you can see, mostly all products are boxy style or quadratic, which coming out mostly from the shape of the single board computer, which is also quadratic. We choose completely different strategy for that from the point of view that we wanted to create recognizability of the product on the market and create design language which will be really, really iconic. And we placed the same single board computer into the circle shape, which was one of the results from our design strategy. And we created completely unique approach on design. As you can see, the client's previous product was very similar to the market, but the new design significantly helped him to distinguish the new product from the crowd. In total summary, it's very important to set the few goals of what has to be for the development of the new products. This is our values and goals what we're trying to achieve with every development. That goals are to create unique design language, as you saw on the previous page, to create recognizable product, which will be really stand out from the crowd and other competitors and will have really long lifetime. The second very important point is the reduction of the investments risks. This can be done by many different ways. It can be reduced by development time or production costs or energy waste or waste in general created during the production. It can be also decreased by a number of revisions based on our previous experiences and many different know-how what we have. What is really important is that we're trying every time achieve support to growth of sales, even in pre-orders, even in after sale, with the influence of the new design language. For us, it's also very important to keep sustainability design strategy. It means that the product will have a long lifetime, it will use the correct materials and create as less waste as possible. Our very strong value is also the transferring experiences and know-how from different industries. which are for one industry really common, but for another not. What is very important is many times not the need of the customer or client by itself, but his customers' needs. And that's what we're trying every time to analyze, validate, and get out the most important targets, what we're trying to achieve also during development. In general, reduction of the R&D investments costs, it's something what can be watched from two perspectives. One perspective is to reduce the development time by not making many iterations with the professional approach and previous experiences. And another approach on this topic can be also from the point of view that by making really smart solutions can be saved many money later on bigger investments into the tooling. We also have very wide network of suppliers at the moment from very different industries and for very different volume of productions. So this is also very helping to speed up the development and later on even manufacturing process. We are able to cooperate on many different levels, could be consultations, could be rebuilding of existing product, partial rebuilding on completely new design language. There is many ways how your brand, your product, or anything what is creating design value in your company can be approached and get better. Thank you very much. I also want to thank to DEBATECH conference and the opportunity to be part of this and reach you all. I believe that the design and industrial design of your products is a very significant part of the brand value.
Feciľak Tamás vagyok, 2015 óta folyamatmérnök az electronica Kft-nél. Cégünk 2019 óta rendelkezik röntgengéppel. A röntgenvizsgálatot ma már az élet számos területén alkalmazzuk, a gyógyászattól, a régészeten keresztül az ipari anyagvizsgálatokig. Mi azonban elsősorban optikailag nem látható forraszkötések vizsgálatához használjuk. Napjainkban egyre inkább elterjedőben vannak azok az alkatrészek, tokformák, amelyek alsó kivezetéssel rendelkeznek, és ezeket hagyományos módszerekkel, mint például az EOI, nem tudjuk ellenőrizni. Ilyen esetben tud nagyon jó szolgálatot tenni a röntgengép. Jellemzően a BGA, LGA és QFN alkatrészeket szoktuk mintavételesen vagy 100%-ban ellenőrizni röntgenberendezéssel. Természetesen a röntgengép csak egy eszköz. Ahhoz, hogy a forraszkötések jóságát meg tudjuk ítélni, megfelelő forrasztási, alkatrészgyártás technológiai ismeretek is szükségesek. Olyan ez, mint amikor egy ultrahang felvételen egy kismama vagy az apuka a fejlődő kisbabát látja, de egy gyakorlatorvosi szám észreveszi az esetleges fejlődési eltéréseket, mivel tudja, hogy mit kell látnia egy ilyen modern képalkotó rendszeren.
It was a great presentation. Thank you. Let's move forward because we are moving right now from company field to academic field. I'm introducing Michal Sojka, who works at Czech Technical University in Prague. Need to admit, this topic is really, really difficult even for me to pronounce and to read. So he will introduce himself. Just in a nutshell, it's going to be about demand for high-performance computing and the safety requirements, avoiding the platforms overheating, and much, much more. This seems to be a robust project. And the question I have for you is, what are your partners? Because I'm sure you need a lot of partners in order to make it realize. So if you can name some of those partners and elaborate further. Over to you.
Yeah.
Thank you very much.
Yeah, so thank you. Of course, this work has been done with few partners, not that much. The main partner was Honeywell company, who produces aerospace components. So the topic actually was from them. And another partner was also Portuguese university in Porto, but with that university we worked together on slightly different topics. So this is mainly between us and the company.
Thank you.
So my work is called software-based methods for peak temperature reduction of modern multi-core chips in safety critical applications. Yeah, so it's complex title. So let's look more in detail what it is actually about. So multiprocessor systems on chip. Those are typical chips used today in modern embedded applications, autonomous driving, drones, and these things. You can see such a chip here in this picture. It's actually the whole computer in a single chip. Besides that single chip, you need just few more chips like memory, some power controllers, and that's it. You have the whole computer. And such chips are used in many applications. They are used not that much in avionics because avionics is very conservative, especially due to safety reasons. And using highly complex chips in avionics in safety applications has some problems. But nevertheless, even avionics looks forward and tries to prepare for the future where those chips will be a part of avionics. And one of the problems they have, at least what they told us, is that the chips have to meet strict thermal envelope, meaning that the chip temperature should be held below certain threshold. And there are multiple ways how this can be achieved. For example, you mount a fence on top of the chip, but having a mechanical component in an airplane is not good because fans are not highly reliable, and relying on the fan is simply not good enough. Similarly, you can have massive heatsink, but massive heatsink it has some weight, and the weight is something that they don't like in the airplanes. So there is another approach, and this is like purely software-based methods how you can decrease the temperature, and this is exactly what we have been looking at. Finally, in the end, I think all these methods will be combined together, but if every method is able to decrease the temperature by a few degrees, that's our goal. So let's look how we proceed with these settings. First, we have developed a test bed where we can measure the temperatures, power consumption, and so on. And we analyzed on this test bed how the chip itself behaves and how the applications that we are using, how they behave from the thermal and power consumption point of view. Then we have created a mathematical model. Based on that model, we perform some kind of optimizations, and finally we validated that what comes out of the optimization really works in reality on the physical platform. So this is mainly the outline of the presentation. And now let's look at how we build the test bed and what we can do with the test bed. We have actually built multiple test beds. So this is just the first one, but as you will see, all those test beds share some components, so the structure is basically the same. So the core of the test bed is, of course, the embedded system with multi-core systems on chip. It's NXP i.MX8 CPU. And this is the target board. This is what we are interested in, where we run our workloads. Besides that, we have an ambient temperature sensor because we need to take it into account when doing experiment. We can measure the power consumption of the whole board. We can control the fan This is used mainly for cooling in the middle of the experiments, because we said that we don't want to have any fans, but just for experiments. That's what we have here. We can control the board remotely, like switching on and off and resetting and all these things. And finally, all of this is controlled by another board, something like Raspberry Pi, but different one. Those are the main components, and besides that, we also had a thermal camera. So now I am going to show how our thermal camera looks like. This is another board that we had in our testbed, but you can see that the thermal camera looks directly at the chip, and we have painted the chip with black color so that the thermal emissivity is higher and the thermal camera can better see the temperature in different parts of the chip. You can also see that we no longer have a fan here, so we can directly observe the temperature on the chip. And this gray thing is just a tube which can flow the air to cool down the CPU to prevent overheating during our experiments. So that's our testbed. Now let's see what the thermal camera can see on this board. The thermal camera see exactly what you see on the left figure. You can see that now the CPU temperature is about 43 degrees Celsius. And if you look directly on the chip itself, which is this red rectangle, the detail of that figure is here. So you can see that the chip is more hot at the, let's say, top right part of the figure and cold at the bottom left. But it has to be said that the temperature difference here is only 1.6 degrees Celsius. So it's not very much. We don't see much details in this figure. Therefore, on top on this figure, we perform some image processing to, let's say, reverse thermal equation, how the heat is propagating through the chip, and based on that equation, we can figure out where on the chip is heat generated. So you can see clearly that there is one heat source on the chip, and there is another smaller one, and yet another smaller one. So this part is somewhere here. This part is somewhere here. So now, next, what we were interested in, like what are those places where the heat is generated, so that we can use it later. To understand that, it's necessary to look at what actually is inside the chip. So here is a simplified drawing of what is there. The most important parts from a temperature point of view are the CPU. So there are two CPU clusters. Here we have 4 ARM Cortex-A53 CPUs. These are smaller, slower, but more energy efficient CPUs. And the other CPU cluster, there are 2 A72 CPUs. These are faster, but they are more energy hungry. Besides that, there are 2 GPUs or 2 accelerators, either a graphical accelerator or video accelerator and display processor. And what is also important from energy point of view is the memory controller. The rest are a lot of other peripherals, but they are not really important for performance, for power consumption. So now we have thermal camera, we know what's in the chip. So let's look what the thermal cameras see in real time. And we have developed a tool which allows us to process the images and see what's happening there in real time. And what you see here is when we execute a workload, and 1 second we execute on one A53 CPU, another second we execute on A77. So you can see on this picture, second from the right, this is where the heat sources are best visible. You can really see that every second the heat source switches from one part of the chip to another part of the chip. So with this, you can somehow get an idea what is in which part of the chip and how the heat propagates through the chip. You can do a lot of interesting analysis from that. So just as a side note, this is like a lot of experiments where we change the temperature of the chip and look at whether depending on the temperature, whether the heat sources change somehow or not. And as you can see, the heat sources are almost always at the same time, at the same place. So let's get back to the chip layout. We performed a lot of experiments, and with those experiments, we wanted to see like where are different parts of the chip and how they can interact with each other from thermal point of view. So on the left figure, you can see with different colors when we executed workload on different parts of the chip, where these were. So A53 CPUs, these are those slower energy efficient ones, are located here. A72 CPUs are located here, and the GPUs are located at the top. It's clearly visible that those more powerful A70 CPUs can be easily distinguished from each other. There is one, there is second one. But if we wanted to distinguish those more energy efficient A53 CPUs, which are somewhere here in the left, we can see that the CPUs are really small and we cannot really distinguish where the heat is produced by them, because this is gray, there is no shade of any color. Similarly, we can see like where the two GPUs are located on the chip. We can also see different parts of the memory hierarchy and how which parts of the chip responds to changing of the chip frequency. So this is all the information that we can get from thermal camera, and you will see later we use it to some extent in our analysis. But before I start talking about our analysis, I will show another video, another testbed that we have built. Now, this is not an embedded system. We wanted to see what happens when you take a desktop CPU and look at it with thermal camera. So what you can see, this is the desktop CPU. Without any lid, this black rectangle that you see in the middle, this is directly the silicon. It's only painted with black color again, so that the thermal camera can better sense the temperature. So what you can see on this CPU, again, we have here the video from thermal camera. Now the CPU is idle, nothing is executing on it. But when we execute a workload, each second there is something executed on a different CPU. On the figures below, you clearly see how that the heat is generated at different parts of the chip. So this way we can see where the CPUs are located, and we can use this information to optimize the temperature layout of the chip and so on. So that's all about our test bed. And now let's look at how we can use this information and other information that we have to optimize the workload and to really decrease the temperature. So first, we want to decrease the temperature, but as you might have seen, the temperature, measuring the temperature it's not easy, because the temperature is influenced by ambient temperature. There is a lot of noise. The resolution of the temperature sensors on the chip is not very good. It's more precise and better to measure power consumption. So here you can see the results of the experiments where we compare the dependency of the final chip temperature with respect to total power consumption. And what can be seen is that it's pretty linear dependency. The more power you take, the higher temperature of the chip is. So that's just a confirmation that physics works as it should work. And thanks to that, in our optimization, we don't really need to measure the temperature. It's sufficient to measure the power, and therefore it can be more efficient and faster to get all the values that we need for our optimization. So what are the values? In order to optimize something, we have to know our workload. In our case, we had few different benchmarks. You can see those benchmarks listed here below the graph. Those are different programs that we want to run on the chip in the final application. And we need to know something about them in advance. And we settled on describing each type of application with just 2 numbers. It turns out that this is sufficient and this is the best. We tried even something more elaborate, but this simple model worked very well. And this model, for each benchmark, we just need to know 2 parameters, O, offset, and A. O means how much is the power consumption increased when you run this application on otherwise idle CPU. And this activity coefficients, this A number, it means how the power consumption increases if you run one additional application on another CPU. So you are actually running 2 applications together, let's say. So, and you can see that those numbers are different for different programs, depending on the program. Some are more power hungry, let's say, some are less power hungry. That's how it is. So this is our power model. Next, we need to understand performance model, because of course, if you run your program on the slower energy efficient CPU, it takes more time to execute it. If you run it on the faster, it's faster. So we benchmarked our programs. These are again simple numbers. How long does certain computation work? And you can see the ratio between the slower and energy efficient CPU and faster and energy less efficient CPU. Some workload is 3.5 faster when running on the faster CPU. For different workloads, it's just 1 point something. So that's the trade-off. You have to decide whether you want fast execution or more energy efficient. And that's what we will use in our optimization later. Next thing that we need to do to know to perform the optimization is how the applications will be executed. In avionics, it's slightly different than in the other industries. They are very strict. They execute their workload based on static time partition schedule, which means that everything is given in advance. There is a certain cycle and execution of those applications, tasks, or partitions, if you want, just repeats periodically. And the schedule, how the applications execute, is always the same. So the schedule is called major frame, which repeats forever. This major frame is split into windows, and in each windows you can have certain applications. They are called partitions or tasks, and they can run on different CPUs. And our goal is basically to find the schedule, where to run the application, in which window and on which CPU. And by changing these things wisely, we want to decrease the temperature. So how we do it? We have an integer linear program, which is a method for mathematical optimization. This is our model. I will not go into details. What's important is that here you see those parameters that I have talked about before, like this activity coefficients, execution time coefficients, or this offset coefficients. So this is the input of our model. We also specify what is our target period of the schedule, the repetition. We solve the model, and the output is how many scheduling windows we need to have and where to put each task. So that's it. Now let's look at the result, how well our method works and whether it can really save some temperature. Here you can see the schedules. This is the result of our optimization, and our method is here at the top left figure. Those rectangles of different colors are those different benchmarks that we have benchmarked before. And here we see the final temperature, which is measured on the real hardware when this workload is executed. To compare ourselves with something else, and we try different allocation strategies, different methods how to produce the schedule. So, for example, this method tries to make the lowest utilization, meaning we want to have as much space here wide, and the result is that this method puts basically almost everything to those fast CPUs, which are more or less energy efficient. And this can clearly be visible on the final temperature. So here, this method is 14% worse temperature-wise than our method. If we do not compare our temperature based on the idle temperature in the room, but if we compare, ambient temperature in the room, but if we take as a baseline the idle temperature of the board when the board is not loaded at all, this is 27% worse than our method. So maybe it's not that likely that people will use will execute everything on this high power CPU. Maybe they use some kind of mix. So we also compared ourselves with some random configurations where the allocation was done more or less randomly, something like what humans could do manually, and we are still a few percent better. So it seems that our method really works. Now yet another picture which compares the benefits of our method. Here we are comparing ourselves not with just another method, but we are also trying to increase the hyper period of the schedule. So the question is, if I can make the schedule a bit longer, does it allow me to save some temperature, like trade the period for the final temperature? And the answer is, of course, yes. It can be seen in this graph. This green line is this lowest utilization schedule, which is like the worst case what you can have if you care about temperature. And orange and blue is our method. So you can see that our method is better. This is what we have seen on the first slide. But then if we extend the period, if we make the schedule a bit longer, we can make this schedule longer by two ways. Either by just rescaling this initial schedule that we had, just make it a bit longer. And the temperature, of course, decreases because at some time the whole CPU does nothing because everything is already computed, so the temperature goes down. But as you can see, if you apply our method in full, if you run full optimization, and the results you can see in these figures in the left, basically what the method tries to do, it tries to move as much as workload from the high performance CPU to the lower, to the energy efficient CPUs. So here at the bottom, almost nothing runs on the high performance CPU. And you can clearly see that there is at the end, there is a huge benefit. So to summarize it with few numbers, even if you extend the period by 21%, if you can save the 11% of temperature. If you just compare this orange and blue, you can already save 3% of temperature, or reduce the temperature by 3%. If you can make the schedule even longer, you can reduce the temperature even more. And if you compare the temperature with respect to idle board temperature, not with ambient temperature, the percentage is, of course, much higher. So that's more or less what I wanted to show today. In summary, this is like the whole thing that we have developed in this project. So we have the hardware, we have a lot of software tools that allow us to get data from thermal camera, measure power consumption, and so on. We can process the results, and we input the results from those benchmarks to our scheduling method, which produces the schedule. And when this schedule is executed, in the avionics operating system, it decreases the final temperature. So that was all in a nutshell. If you are interested in more details, you can find the details in the paper that we have published last year, which received Best Paper Award at RTCSA conference. If you are interested in doing something similar, maybe our tools might be handy for you. Those are all open source available at here. And last but not least, if there is somebody from industry is interested in doing something similar, usually what we do is some kind of optimization combined with embedded systems. We are open to collaboration. There are different ways how companies can collaborate with us. Both have the advantages, disadvantages. If you think it might be a good idea to collaborate, feel free to contact me and we can discuss the best way. That's all from me. Thank you for your attention.
Nice presentation as usual. The next one are partners of SOS Electronics, our partners from Lantronix. Lantronix is a global hardware and software provider for Internet of Things, simply IoT. They are a pioneer in secure networking technologies. Our next presentation will be related to this specific security field. Handing over to Lantronix guys.
Hello. Yes, a very good question. That's totally accurate. Lantronix is a solutions provider with a very strong focus on the IoT market. But perhaps allow me to give you a quick overview of Lantronix, who we are and what we do. Lantronix is a US company founded in 1989. We have our headquarters in Irvine, California, and we are a public company listed in NASDAQ. We have a global presence with offices in North America, Europe, and Asia. Lantronix has historically been known as a hardware manufacturer, but this approach started to change in 2019, so 3 years ago, when Paul Pickle was appointed CEO of the company. Since then, we have been moving more towards a solution provider, and on top of that hardware, we are now adding services and software in order to be able to deliver solutions to our customers. Our IoT core building blocks are identified by 5 C's. Those are collect, connect, compute, comprehend, and control. We typically represent this as a circle because not all C's may be required from our customer when doing their applications. But when turning this into reality or taking it into practice, it may be easier to visualize it as a stack. So collect is the ingest of data from field sensors. Many of our devices can connect to this kind of sensors via input and output serial interfaces such as RS-232 and RS-485 or Ethernet. The sensors are typically selected by our customers and most likely from third parties. Connect is where our devices start to come into play. Customers would use our devices and gateways to connect or transport the data from the field sensors to the remote cloud. The connect block works in both ways, allowing the gateway to report the data from the field, but also enabling communication from the remote platform to configure or troubleshoot those field devices. Besides connecting the field and the cloud elements, the gateways can also perform some computational operations on the data that is being gathered. This is compute layer for us. For instance, if we are collecting temperature data from a sensor, it may not be needed to push all the data points if the temperature does not change significantly. In this sense, the gateway can buffer the data locally and then transmit it when it is needed. We could also set minimum and maximum thresholds as alerts and transfer the data immediately without having to wait for the next transmission period. The gateways are also capable of normalizing the data, so it is transferred in a way that the remote platform can consume it right away without having to modify it before storing it. Control is applied on the remote platform. For us, this remote platform is ConsoleFlow, which by default we offer as on-cloud deployment, so it is a software as a service approach. There's also an on-prem version of ConsoleFlow for those customers that require installation in their own infrastructure. This remote platform, ConsoleFlow, enables device management in the sense of applying remote firmware updates and configuration changes, as well as retrieving health monitoring data periodically from the devices in the field. Using the APIs implemented in our devices and gateways, the data is securely transmitted using port 443, both for HTTPS and MQTT-DS. In this sense, the data is encrypted both in flight and at rest. Comprehend is the last layer in this approach, and it is often in the customer's application space. ConsoleFlow REST APIs can be used to push CLI commands and update jobs and trigger device management tasks. Ultimately, customers will be using the APIs to retrieve telemetry data from their devices and run their business intelligence according to that information. As you can see, this can apply to different end customer applications, such as building automation and PoE lighting, traffic management, security and video surveillance, industrial automation, or fleet management, to name a few examples. Defining an IoT solution is based on three key pieces in our approach. We mentioned the hardware, which of course we are still building, and we are still a hardware manufacturer. But on top of that hardware, we can now incorporate value-added services such as connectivity services, which is basically an Lantronix SIM card to provide cellular connectivity to those devices and gateways. It can be VPN to secure the cellular data channel, or level technical services to provide advanced and dedicated support to the customers. And also, as we have mentioned, ConsoleFlow as the remote management platform to essentially manage the devices from a centralized point. We talked before about 5 C's, and we needed to add probably the most important one, C, which is the 6th C would be the customer. It is critical to understand the customer application to make sure that we are proposing the right technical solution to their use case. And equally important, it is are our strategic partnerships. In this sense, SOS Electronic is one of them. It is a very long-term and strong partnership between SOS Electronic and Lantronix. And for us, it's very important because of the local reach in different territories in Europe and approach in each language in the countries. The team is very knowledgeable and dedicated to the Lantronix solutions, and they are spanning also the Lantronix portfolio and capabilities with IoT and out-of-band solutions products in the region. Lantronix is now focusing basically in 6 verticals. We mentioned a few of them, but to summarize them would be transportation, smart city and utilities, enterprise, connected healthcare, manufacturing and agriculture, and retail and consumer. So let's see a couple of examples or use cases for each one of these verticals to give you an idea of how some of our customers are using our products and solutions to tackle their applications. The first one of them in transportation is a traffic management system. This is something that we are doing with the New York City Department of Transportation. They have a cabinet on the roadside in strategic junctions and intersections around the city. In this cabinet, there's a bunch of equipment. Their main device is the traffic controller. But then there are a couple of Lantronix devices such as the PoE Ethernet switch and the cellular gateway that provide the connectivity for the remote management and surveillance of this system. We want to highlight in this approach the PoE Ethernet switch. Obviously, being PoE allows to power traffic cameras directly over the Ethernet cable, and in this sense, they are benefiting from a feature that we call APR, auto power reset, which in essence our switch can ping the IP address of the IP camera, and if we don't get a response to that ping request, we do a power cycle on the port to do a hardware reset of that device. These devices and solutions are now approved by 3 Department of Transport in the US, those being New York, Florida, and Georgia. Another kind of transportation use case that we typically are involved with is with fleet telematics devices. We have our FOX3, which is a telematics gateway. It is a device with a GPS and GSM capabilities. So in essence, it can send the GPS location to a remote server over TCP, and in this way, it can locate in real time the vehicle of the device. We can also interface it with CAN bus, which is the basic, the main communication bus for the control units inside vehicles, and basically with this we can complement the location with all the telemetry data of the vehicle, and we can even get as well some data from sensors over Bluetooth as well. Another vertical, as we said, would be smart cities and utilities. One thing that we have started adding to this vertical since 1 year ago is PoE switches, and we have seen that there has been quite an evolution in the PoE space, because the technology at the very beginning it was 15 watts to power the basic cameras, for instance, but now we see that it's very common to require up to 90 watts because the cameras have more definition, and in some cases they need heaters depending on the weather conditions, and also these PTZ pan tilt zoom features, so that they will require more power because of that. In this sense, one of the key use cases that we see for our switches is in the building automation and PoE lighting space. We have devices, switches that can deliver 90 watts per port on all 24 ports of the switch. So that means that is 2,160 watts power budget that we have available. And with this, the customers can use this to provide both Ethernet connectivity and power to the devices in their buildings. There are very specific use cases and quite interesting, such as the Sinclair Hotel. This is a hotel in Texas, in the US, that has replaced their AC grid with a DC grid based on the PoE. And because after doing that, they have seen energy use savings of up to 35%. In this use case, they have pretty much everything in the guest and rooms in the hotel powered by PoE, such as occupancy sensors, smoke detectors, refrigerator, the TV, the door locks, everything is powered by PoE and managed remotely from our switch. Another good example in this vertical, it is a PV plant monitoring, so photovoltaic and solar. We have our cellular gateways, such as the G520, that can be used in this kind of applications. The G520 is a very capable device, a very it has a lot of features and interfaces. In this kind of applications, Modbus is very used a lot. And basically, we can connect to Modbus slaves over RS-485 and also over Modbus TCP, depending on the kind of slaves that the customer would have on such a facility. The device, as we said before when we were referring to the compute layer in our IoT approach, the device can pull the data from the Modbus slaves. It would store it locally into the device, and then it would transmit it to a remote endpoint periodically as defined in the configuration. On top of doing this, it can also support VPN capabilities, such as OpenVPN or IPsec, which are the most used ones by our customers. And this is basically to perform remote maintenance tasks over a secure channel. In the enterprise use space, I would like to highlight a couple of applications and use cases that we have. One is a secure remote out-of-band management. This is a combination of one of our hardware devices, the Lantronix SLC 8000, which is a modular console manager. A console manager or console server refers to those devices that can connect to the console port of network equipment. So in these big data centers, our customers would have network switches, firewalls, routers, servers, even UPSs as well. And our SLC 8000 allows secure remote connection to these devices. So it means that if anything breaks because of a bad configuration change or any issues with a firmware update in this network equipment, the network team would still be able to get access over the console port and try to recover the communication with that device without having to physically go into the data center, which can be costly, obviously, because of the travel expenses, but it is not also so easy because they are very secure, and typically you will need to apply for a security clearance to make sure that you would be allowed into the building in the first place. And also combining this with console flow, the customer can from their browser, from their office, they can get to the console interface, so the command line interface of their network devices in a very convenient way. There are some other use cases where we are using media converters to provide a very low latency connection between data centers for our customers. These ones are being deployed for different companies, and they have one of them in specific. They have as of now the Lantronix solution deployed in 3 different states in the United States. The fourth vertical, which is very popular as of now, it is connected healthcare. We have different devices that are certified for connection to medical devices. The main one being the SGX 5150 MD. MD stands for medical device, and it is IEC 60601 certified. As I said, this means that it can be connected directly to medical devices, and this certification is for that. So the SGX is a very interesting device. It is packed with a lot of interfaces. It has serial ports, basically RS-232 or RS-485, to connect to the medical device. It also has Ethernet and Wi-Fi. The Wi-Fi can be both access point or client mode. So in this sense, the customer would be able to connect any legacy equipment inside the hospital or the clinic over the serial port, and using either Ethernet or Wi-Fi, they would be able to send the data from this equipment to their management platform, which, being a hospital, most likely it will be on premises. It can also be console flow, because as we have said, we allow or we offer an on-prem version of console flow for this kind of requirements. We have also some other customers that, based on our modules, in specific embedded modules, such as the Lantronix XPICO 200 series, they have developed and implemented medical equipment for rapid molecular diagnostics. Okay, so the XPICO 200 is a very interesting product offered in several different models with LGA or edge connector variants, also with on-module or external antennas, and even with a Bluetooth or without Bluetooth, and also with a Wi-Fi 5. This is the 11AC standard. It has a very small form factor, so this enables our customers to integrate it into their hardware, and even if it is a very small device, it is quite complete in terms of the Wi-Fi security compliance. We have recently implemented a WPA3 security for the Wi-Fi. This device it is also can also be managed from console flow, allowing the customers to very easily upgrade and add new features to their devices without having to touch their design. Another very interesting and key feature is the global certification of the device. So it has a modular certification, which will make it a lot easier for our customers to certify the end product. Industrial grade operation in temperature -40 to +85 Celsius degrees, and we also provide an SDK. So if customers needed to add some extra features, which as of lately two of the most requested ones are compatibility with Microsoft Azure or MQTT communication protocol. Those can be supported with the SDK, and our customers can modify or add their logic to make the device work with their current systems. Another key vertical for us is manufacturing and agriculture. We have. I want to highlight another couple of use cases here. One of them is intelligent farm equipment with a German company that we are cooperating with. It uses again the FOX3 that we saw at the beginning, and with this FOX3 device, as we have said, they can collect the real-time location of the equipment, but also they are using the BLE Bluetooth Low Energy with specific sensors sensors to identify when the machinery is being attached to a specific tractor. So for them, this has enabled a new business model in the way that they can know which machine is being associated to which tractor, and this makes it very easy for them to keep track of these rental machines. Another very interesting use case in which we have been in which we have taken part is a pipe manufacturer that they are using our cellular routers with connectivity services. As we said, these are Lantronix SIM cards to provide connectivity for their machines. They are doing predictive maintenance and also secure remote access for troubleshooting. So on top of the SIM card, they can use what we call a remote client VPN access, and this means that without having to install anything in their infrastructure, just a software application that can run either on their laptop or smartphones. With that and enabling the firewall rules in the router, they are able to get remote access to the router first, and then to their machine wherever the device is deployed in the world. This for them has reduced significantly the travel expenses that they had in the past when using regular SIM cards. The last use case that is also very popular amongst our customers is retail and consumer. In retail and consumer, we have a couple of different approach. One is again our XPICO 200 series. We have customers implementing those in commercial weighing scales. And this means that there's a small serial to Wi-Fi module inside the scale, and based on information that is retrieved from the serial port, it is wirelessly transmitted to the point of sales system inside the store. So it will make it very easy to send the data from the scale to the point of sales system, and without the hassle of having to use wires or Ethernet cables. Another one is shopping surveillance. So we have seen previously different use cases using our switches. This is a combination as well of our switches to power the PoE cameras that enable the surveillance, and also our cellular router to provide the cellular backhaul to those switches. Again, the switches highlight again the APR feature, auto power reset, which we can power cycle a specific IP camera if no ping response is received from it, and all of these can be added to console flow for centralized device management and remote monitoring. Also, this in this specific case, connectivity services for global cellular communication is used as well. So those are basically the main applications and use cases where we are focusing, depending on these six verticals. And I would like to encourage you, if you want to know more, to go to soselectronic.com/Lantronix or to lantronix.com, where you can find all the information and latest documentation regarding these products and solutions. Thank you.
We have reached the end, ladies and gentlemen, technology enthusiasts. We went through many interesting topics. It is the end for us here in the studio, but not the end for you, because we will be sharing all materials, all videos, all presentations in social media, on our platforms. We really hope that you've enjoyed our presentations, you've enjoyed our speakers, and we are looking forward seeing you on the next conference. Thank you very much.
The world we live in has just one way to go, into the future of technology. Our mission is to be part of this journey. We are reinventing the way of electronic components distribution. We are there at the tops of the highest mountains and the bottoms of the deepest oceans. We are there in the killing frosts and the roaring flames. We are there where one's life is celebrated and another's is struggled for every day. From the simplest to the most imaginative solutions, we can help you reach your goals. If you wish to use the light of the sun, if you desire to tame the power of the wind or the sea, if you want to drill deep down or reach up for the stars, we will be there. SOS Electronic everywhere.